friends, welcome to Coding Garden with CJ. Welcome to an Arduino stream. We're going to be programming an Arduino. I have some fun things today. We'll possibly be programming this RGB LED matrix, or this thing. And yeah, welcome to the show. So to program it, we are going to use a library called Johnny5. If you tuned in a few weeks ago, we made this simple little LED thing. It's not running right now, but that's running on an Arduino with Johnny5. We're going to try to do something similar. So let's say hello to all the people in the chat. Hello, Ronnie. Welcome. Hello, Katoli. What's up, Doc? Hello, Shaggy. Hello, Daniel. Hello, Tipsy. Yeah, and Chad says, is Johnny5 a person or a library? It is a library, a JavaScript library. And hello, Dan. What's up? And hello, Kamal from Istanbul. Welcome. And Infi says there's a huge hurricane in Central Europe right now, so watching a CJ stream is really nice because it distracts from the sounds outside. Well, I'm glad that I can be a distraction, and that's really unfortunate that there's a hurricane right now. Hopefully everything is okay. Hello, Bill. Conrad's in Germany too. They're in the chill part of Germany, I guess. And hello, Free Debugs. What's up? Yeah, it's been a while. I guess I didn't do a Kata stream this week. No, I only did one stream this week. Yeah, I haven't been streaming that often. I've been busy. Yeah. Tipsy says, I'm really down. No job, no skill. Not earning anything. Already 22. What do I do? I wouldn't say you have no skill. You know how to program, right? Or you're learning how to program. I would focus on that. You are watching this show. Yeah, I had to fix the drop game. There was a slight bug in it. The stream is right now, and hello, David. Welcome. Hello, Sacred Gaming. Yeah, the LED isn't. I mean, it's technically sitting here on my desk. I could turn it on. I think I will. I'll turn it on, at least until we figure out what we're gonna do. Wouldn't you like to be a pepper too? What? I don't know what that means. Hello, Ed. Welcome. Hello, David. Hello, Ran. Good day, Chris. Hello, the Oxty. What's up, Terrazoid? Hello, Alka. Hazrat says it's 4:23 a.m. in Bangladesh, and I'm here. Well, welcome. Hopefully, I'm not keeping you up. Get some sleep if you need it. Hello, Yaomi. Welcome. Sujan says it's already 3 a.m. I'm not going to sleep now. All right. Well, we have to decide what we're going to do. So first up, I'm going to get my LED thing running. Oh, not that. This I term Arduino. Nope, there's no npm script. That should be running now. And then we need my webcam preview. Let's take a quick stretch. Oh, it's a quote from the movie. Okay. I'm pretty sure I've seen the movie once, but I don't really remember much of it. The Johnny5 movie. Webcam preview. There we go. Cool. So there it is. So if you send the command !LED and with 8 bits followed by 8 bits like that, like Shaggy just did, it'll turn on the corresponding bits. So that's the thing that we built last time. There you go. Nice message from Acid Spark and one from Kamal. Sure, yeah, so Alka mentioned they were gonna make a PR. Feel free. Yeah. And hello, Pickus, welcome. Okay, so it's about to be the worst of it. That's unfortunate. The drop game doesn't like my emotes. What are you dropping, Sacred Gaming? Because I could fix that probably. Oh, this one. Oh. I don't have... Oh, that's working. Maybe it took a second to load the image. Yeah. And hello, Hector. Welcome. What's the difference between an interface and a type? An interface is like a contract. An interface describes the attributes of a potential type. A type is like a blueprint. It's a blueprint for creating types. like a class. A class I would call a type. An interface is just an interface, but a class can implement an interface. I don't know. And hello, Brian from Peru. Welcome. And hello, Pranjal. Welcome. Interface is like a definition, a specification, a guideline for an object. Type is more custom. Cool. Yeah, a type actually implements methods and has a constructor and does the work. And hello, said Za from Peru as well. Welcome. Oh, Pranjal installed Anonymous Pro today. That's the font that I use in my editor. Cool. So, hello. What's up, Doc? We need to decide what to do. So, what I have here, actually, I'll put it on camera real quick. What I have here is a 40 RGB LED matrix. So each one of these LEDs can be lit up to show a any RGB color, and we can do a lot of interesting things with this. One thought I have in mind is we could make it so that you could send a message in the chat to change one of the pixels to be a certain color, and then people can basically send a bunch of different messages to light up the different colors of the RGB LED matrix. And the thing is, I actually have two of them, and these can be chained together, so we could even do something like that, or like that. So there's that. Yeah, that's a good point, David. So David says, I'd like to see a larger display and make Snake or Tetris on it. That'd be really fun. So this is another thing that we have. I'll put this here. And this, we probably couldn't play a game on it, but we could make some scrolling text. And there's Win32 Day, which is very relevant because, so basically when we hook this thing up, just this 8-bit LED thing, we used a shift register. So that's this little chip that everything's plugged into. It looks like this. Like that. So this little chip is a shift register, and what it allows you to do is to send it a sequence of commands, and it will then store that so that it can light up the LED. So this actually has 8 outputs on it, and it's controlling 8 LEDs. So when you send a command, we're registering it on the shift register. But this thing is pretty complicated to program. And last time we tried to program one of these, but we couldn't figure it out. So I did this first. And I got a message from Win32 Day that actually figured it out, who basically said you could do it, but you need 2 shift registers. So he actually sent this GitHub repo where he has that same LED matrix, but then you're using 2 shift registers. I think that's what they're called. Am I saying the right thing? Yeah, shift register. And basically what happens is the combination of the 2 shift registers allow you to send enough signals to turn on or off any LED on this little matrix thingy. It's doable, but it's a lot of wires, and the programming is a little bit more complicated. This has the Max 2719, is that what it's called? Yeah, 7219, the Max 7219 chip, which makes it really easy to program. As you can see here, there are only 4 places for us to plug into, and that will allow us to program this entire thing. And it's actually 4 Max 7219s in a chain powering all of these different matrices. So this is actually going to be a lot easier to program without the shift registers. But huge shout out to Win32 Day for sending this right up, because if all you have is one of these and 2 shift registers, you can make it work. Yeah, Dan is saying 8-bit shift registers are like signal multiplexers. Yeah, so you can send it, basically, I think there's only 1 output pin coming. I may be wrong, but I think there's potentially there's just a few pins coming from the Arduino, and then the shift register actually allows you to light up 8 LEDs rather than just the 2 or 3 pins that were actually plugged into on the Arduino. So, but we don't have to use that today. We have this if we want to do it. So, I think it's full 24-bit. Yeah. So this is actually a knockoff of the Adafruit NeoPixel. Let's look that up. Adafruit NeoPixel. That little bit smaller. NeoPixels, yeah. So these are cool. And they have a lot of different ones. They have like a ring you can get or just a stick. This one is a knockoff of the 40 RGB LED one. This one. Wait, no. That's a 4x8. That's an 8x8. This one. And this one sells for $28. I actually got this for like $9 on Amazon. So this is what we're dealing with. And it's really cool, actually. I didn't have to do any soldering. It comes with the head extenderizer thingies, and these are already on there, so I can just plug it directly into the Arduino. So it's ready to go. And you can send any hex color to it using the node pixel library. So yeah, let me catch up on the chat, and then we'll decide what to do. I think we'll take a vote. I think if we do this one, it's gonna be anyone in the chat can like send text to it, and the text will scroll across. And if we do something with this, anyone in the chat can send a command to change the color of any given pixel. That's the plan. So this was to that question earlier. I use types to put things together. So command is a message and a command type. And hello, man on the run. Welcome. Types are good for when you want to allow certain strings only. Sure. RGB, yeah. Sacred Gaming is saying you're gonna need some shades if someone sets them to full power all white. I've actually played around with this a little bit, and it's blinding. It is so bright. And I messed around with like converting an RGB value to an HSL value, and then changing the L value, which is the lightness value, to make it not so bright. So if we do that, we'll probably do something like that, just so this doesn't blind us. And also, it would probably be so bright that it'd be really hard to even see on the camera. So we're gonna have to do some dimming for sure. Oh, we could do Connect 4. Oh man, that would be fun. Connect 4 on this thing. Yeah, you could like join a team. I like that idea. You could join a team, and one team is red, one team is blue, or whatever the colors are, and we could play Connect 4 on this. That would be interesting. I guess we could do Connect 4 on this too, technically, but it's really big. If eventually, if we don't do this today, I want to do something with scrolling text, because that would be fun. RGB, Linus TechSips joins the chat. Plotting images. Yeah, the thing is, this is 8 by 5. So it's actually pretty hard to represent even like pixel art with this thing, because it's not very big. But you could scale down an image to 8 by 5 and try to render it on here. A game of Battleship, that could be fun. Yeah, welcome. Pixel emotes, yeah. Hello, Pierre, welcome. And thanks for the follow, Hypo Micro. Thanks for the follow, Iron J. And hola, Gerald, welcome. Rick Astley on an RGB LED. Hey, what's up, Brickzerker? Welcome. Avi says, I just joined and wanted to say I love your videos. Keep up the amazing work. I've learned a lot from you. Well, thank you very much, Avi. And thanks for the follow, Hit Heart. VS Code has an extension to simulate those Adafruit projects. That's interesting. I wonder if the USB port would power all the dots on the white one being on at the same time. Yeah, it will. I've messed around with it, and this thing gets really bright. Have I implemented WebRTC? It has nothing to do with LEDs, but I'm just implementing it, and it's a real pain. I have. It's a little off topic, but if you tune in on like a Q&A stream, you can ask me, because I have worked with it. Yeah, you could do exclamation mark text, and then the text could scroll across this thing. Yeah. Hello, Mahidra, welcome. Drop game on the board? Drop game on here? And thanks for the follow, KS. Epileptic Rainbows. Hello, Aman. We're doing some hardware programming today. It's going to be fun. Connect 4 is actually not a bad idea. I like that idea. Docker with TypeScript React. Wait, this is a question. I install node modules inside the container, but TypeScript's complaining to me in VS Code to install the dependencies, so I have to install the node modules in my system too. I think so. Like when you're dealing with TypeScript in your editor, it needs all of the dependencies to be installed so that it can infer the types and give you IntelliSense. So yeah, you install them in both places, but they're really only being used inside of your container for the app. They're being used in your IDE for TypeScript. Yeah, so that was my other idea, is the collaborative pixel art, where anyone in the chat can change an individual pixel to be a color, and you have to collaborate to draw an image of some kind. Rick rolled me on my own RGB. No, so Johnny 5 is a library for programming Arduinos and other microcontrollers with JavaScript. So that's what we're going to use. David says, what are you using to allow Node to continuously communicate with the Arduino? Yeah, so this is a great question, and this is basically how Johnny 5 works. So the Arduino that we have right here is actually running a firmware on it called Fermata. So there's my Arduino, and it's running a firmware called Fermata. And what Fermata is it's basically just listening for serial commands, and then when it gets certain serial commands, it can do certain things. So Johnny 5 is written on top of that, and it's basically a communication protocol. So right now, the USB is literally plugged into my computer, and whenever someone sends a message, I have a Socket.io listener in a node.js app that receives that message and then sends a message to the board over the Fermata protocol. But the code is actually extremely simple because of the way Johnny 5 is written. But that's one of the caveats of Johnny 5 with an Arduino, is that it will only work if the USB is plugged into your computer, because it's not actually writing programs to it, it's just sending it messages over serial. Yeah, and this code is actually on GitHub. If you go to github.com/codinggarden/LED 8-bit LED, you'll find this. So this is just a Node app. I bring in Johnny 5. I'm bringing in Fetch to make a request to my backend, and Socket.io to listen for new messages. So I have a custom backend that's aggregating Twitch chat and YouTube chat, and when it sees a message, it will then send the message to the Arduino. So when the board is ready, I connect to my Socket.io server, do some custom stuff there. Shift register is provided to us by the Johnny 5 library. We tell it what pins we're on, and then whenever I get a socket message, I then eventually send that value to the shift register. This is just like validation logic. And there's also a queuing thing. So if multiple people send a command at the same time, it queues them up and then shows them one at a time. But this program is literally running on my computer right now and sending commands over USB over the serial communication. So this is actually the Johnny 5 program that's running. So for the RGB LED or the other one, we're going to set it up in a very similar way. It's going to be listening for chats and then sending messages via the USB. John says, I found a tip on returning an int array in Java. Use arrays.toString. Interesting. Yeah, I'm not super familiar with Firebase tipsy and jumps. I'm sorry. Yaomi says, I haven't programmed for 2 months. Any ideas on what to code? Look up like the 100 Days of Code challenge or 30 Days of JavaScript and just pick something. Just pick something and code it. It'll get you out of your rut. Hello, Kamal. I'm not doing any Rust. No, we're doing mostly JavaScript today. Yeah. Hello, Jorge. We're gonna do some hardware programming. Yep, it works with Node too. And so it's basically just a firmware that's listening for serial messages, as far as I understand it. So yeah. Take a quick stretch. So with my understanding is with the Fermata firmware, literally any general purpose programming language that can communicate over serial could technically control the Arduino. Yeah. I'm gonna run it on a separate one just so I can keep that circuit hooked up. But I have like 10 Arduinos, so yeah, I'm gonna use another Arduino. Though you can program the same Arduino to do multiple things. So the Arduino has many general purpose inputs outputs. So all those things along the bottom there are potentially outputs that you could plug into to send signals. The only thing you might run up against is having enough power, but you can use external power as well. Is it possible to run a node server from Arduino/Raspberry Pi? Not from an Arduino, but yes, on a Raspberry Pi, because an Arduino is a microcontroller. It's very dumb. It can't do much, but a Raspberry Pi is a full-fledged Linux computer, so you can absolutely run Node directly on the Pi. Right now, Node is not running on the Arduino. Node is running on my machine and sending commands to the Arduino. Yeah, go for it, Impy. Try to XSS me. You think in my chat? Is that what you mean? Or stack? Go for it. Hello, Cybermind. Welcome to the show. Thanks for appreciating my content. Yeah, so if you have a Raspberry Pi, you technically can run Johnny 5 directly on the Raspberry Pi and directly control the GPIO, the general purpose input output, without needing to be connected to a separate computer. The lights are based on a command. So if you do !LED followed by 8 bits, it'll control the light. And we're going to do something very similar with something else. So that's the plan. I'm using CI/CD with Travis. Do I have to use CI/CD with Docker or keep using with Travis or GitHub Actions? This is a confusing question. So CI/CD can work. CI/CD is either Travis or GitHub Actions, and both Travis and GitHub Actions support commands running in a Docker container. I don't know if that answers your question. Socket programming, or in this case, WebSockets, is real-time communication. Sockets in general are like just a programming concept that is beyond the web, but WebSockets is a protocol for real-time communication on the web. And that's what I'm using here, because that's what the server that's taking in the Twitch chat and the YouTube chat, that's controlling this overlay and the messages over there, it's running Socket.io. Yeah, I'm mentally prepared because I made some updates to the chat window today. So go for it, Impy. And hello, Reed. Welcome. There's a timeout of 30 seconds on the LED command, so you have to wait about 30 seconds. Thanks for the follow Evil Hitman. Yeah, so we rated Laboratory 424 before, and he's rated us. Yeah, it's a great channel. I know he has like a giant LED that people can control, which is really cool. Hello, Ben. How can I make a one-time URL with Express? What do you mean? I don't know what you mean by that. 10 times Arduino's flex. Oh, nice. Yeah, so the WS2811, I believe that's the same thing that's powering this. Adafruit just branded it as NeoPixels, but I believe it's the same thing. They're basically individually addressable LEDs. Okay, let me know, Infy. So it's a drop game thing? It's not the live chat overlay? Yeah, that's an app. If you do !break, you can get a link to my break timer that I use. Oh, a vulnerable username. Oh. Okay, cool. Mahidra, I'm glad that helped out. Thank you. Have you Code Parade? Oh, have I seen? I was like, what? No, I haven't. Code Parade, is that like a YouTube channel? Let's check it out. Code Parade? Is this it? Where he made a simple game console with an Arduino. Building an arcade machine from scratch? Is that the one? Cool, I haven't seen it. I'll probably check it out later. And thanks for the follow, the Twitch librarian. Welcome. That's another good idea. So let's get a poll going, because we got to start coding. What should we build / program? New privacy policy. Okay. Connect for game on RGB LED matrix. Live subscriber / follower count on just like LED dot matrix. Anyone can show scrolling text on the LED dot matrix. What were some of the other ideas? Yeah, the Connect 4 game. Oh, we have Battleship. That would be actually really, it'd be tricky. I'm just trying to think how the game dynamics would work, because for this, really all that's going to happen is this is going to be on screen, right? Everyone's going to be able to see this and see what happens to it. So if you're playing Battleship, something needs to be hidden. It could basically like generate where the ships are, and then people could try to hit, and if it hits, it lights up red. We could that would probably work. Yeah, that'll work. Simple battle. It's kind of like it's like it would be the chat versus a randomly generated Battleship game. It wouldn't really be 2-player, but let's just say Battleship game on the RGB LED Matrix. All right, what were some of the other ideas? Remind me. Oh, like a one-time token? Sure. It gets complicated. So you could generate a global unique identifier and then store that in your database, and then after it's used, remove it from your database. It really depends on what you're doing. The long thin LED would be good for Tetris. Oh, we could play. How would we make that collaborative with the chat though? So the chat has to send commands to like rotate the piece and move it. That would be really hard. I don't want to do Tetris. That's really hard. Hello, Angus. Welcome. Thanks for the follow. Yeah, like Derice. The PR has been PR'd. Let's check it out. So Alka mentioned he was going to make a pull request to allow you to send an animation command to the LEDs that we have going on right now. Let's see what we got. Initial refactor. Did you just refactor it? I thought you were going to do animations. Okay, the refactor rearranges and breaks down a lot of the code and adds type definitions for ease of use with incoming fetch data. Interesting. Did you need to refactor it before you added the animations? Is that what it was? Let's do side by side. How do we do side by side? Is it this? No, I don't know. Oh, it's Sebastian. Okay, yeah, I haven't seen it. Sounds interesting though. Oh no, I did check your PR totally, but I've made changes locally that I never pushed up, and there's gonna be some merge conflicts. So I didn't have time to merge it today, but I will try to do it before the next stream. But I did look at it. Oh yeah, viewer count. Why not? Tetris. Tetris sounds really hard. It might not be, but I don't want to be here for 5 hours. Game of Life. That could be cool. I want it to be interactive though. Because Game of Life kind of just plays out based on rules. But you could technically like send a command to turn a cell on to make it come to life. Yeah. YouTube bar from left, Twitch on the right, more comment, more length of platform. Yeah, like Dryce says, you could totally do a live sub count in binary. Give the viewers a challenge: light off 0, light on 1. Well, I want to use this. So we have this LED matrix, or we have this RGB LED matrix. This one here was like our first go at things like a week or two ago, and now we're ready to step our game up to something a little more complex. Do we deploy Docker, or do we deploy code with help of Docker? Typically, you'll have Docker running on some remote server, and you will put a Docker image on that server, and that image will be running on that server. Too much. Collaborative art. Oh, yeah. I totally forgot. So, collaborative pixel art with the RGB LED matrix. So anyone can send a command to turn any LED any color, and you can work together to try and create art on this thing. That's one that I'm partial to. Make a display driver and build different games and apps on top of that layer. I'm kind of gonna have to. So whatever we decide to do, a lot of it can definitely be generalized to make things easier in the future. But yeah, I totally agree. Where do I publish my webpage? What site? What do you mean? What webpage? What site? Could we do Pong? How would Pong work with the chat though? Okay, that's good to hear, Infi. Awesome. And thanks for the follow, Angus the Bus. But yeah, what do you think? How could we do Pong collaboratively? And it's also not that real time because there's delay. Yeah. Too much latency. Yeah. Yeah, Game of Life would definitely look cool, but I want it to be interactive so the chat can basically control it. Oh, the animation part has been done? Okay, I'll look at it in a second. I'm 3 minutes behind chat. How would I moderate the scrolling text? Just like a profanity filter. That's about it. I can do, yeah, we could do that. Latest follower, sub, donor, displayed on LED dot matrix. And so just to clarify, this is the LED dot matrix. It is, let's see, 1, 2, 3, 4, 5. It's 8 times 4, which is 32. So it's 32 by 8. So this really lends itself to scrolling text. And this is just 8 by 5, which lends itself more to... and also this is full RGB color. This one is just red. So that's what we're dealing with. This is the dot matrix. This is the RGB LED matrix. Yeah, I don't know, Loner. That's a little off topic. Yeah. Tetris could move every 30 seconds. I like that. A fixed slot machine in 4x4? Oh, I don't know. The split view is the cogwheel. Okay. Make a dice roll? I do not play Counter-Strike. Yeah, so it'd be very similar to r/place. Snake game? It just becomes difficult for the chat to control when there's that much delay. Yeah, that's true. 32. Quick maths. Twitch plays style controls for the games with Twitch versus YouTube. Twitch versus... I don't want to turn this into a competition. I like collaborative things, but I like that idea. Cool. I like that, Alka. I honestly feel the same way a lot of times with code bases. Like, I want to refactor it first before I start to make changes, which often is unnecessary, but yeah. Yeah. Hello, Abdelhamid. Welcome. Okay, I think these are our ideas. Let's vote. I am very giggly. Hello, Mr. Waffles. We're gonna vote now. What should we do? I have the final say in what we do, because I don't want to be here forever. But vote now, please. A sound visualizer. I like that idea. But also, it can't be controlled by the chat, so... But I like that. That's cool. Because you could absolutely do little, like, sound waves and stuff. IP duplication checking, yeah. All right, so let's while we're waiting on people to vote, let's review Alka's code. Code updates. So that still does the same thing. This was moved to the top. Where did that code go? Get streams, okay. Get live chat ID. Cool. Valid binary part. When we get a message, do that. Explicitly set the state of the LEDs. Cool. And we got some type definitions. That's cool. Oh wow! Did you actually did you run my backend, Alka, to get this, like, to test this? It's crazy. You got all the type definitions going. Okay. So I want to see the part that animates. Okay, so if the message does not start with exclamation, we're done. Otherwise, we get the parts which come after the command. And if the command is equal to LED, we're going to do LED command. Okay. Cool. Okay, so I think what this will allow is wait. No, I just okay. Parts at 0 is going to give us the first 8 bits. Okay, so yeah. I get it now. there is no animation. That's fine. We'll merge it. Approve. Yeah, I'll merge it, pull down the code, and see if it still works. Hello, Debursik, who is on the record leaderboard for Coding Garden drop game. The leaderboard isn't up right now, but last time Debursik got a 100 in the drop game. Yeah, okay, so we merged it. Let's pull the changes down locally. Yep, he's the one. So, cool, yeah, so it's not TypeScript, it just has type definitions that the editor can use. So, technically, it should still be able to run it. Error. res.json is not a function. Let's see. Oh, you forgot the await. All right, somebody try an LED command now. It's all good. It's not working. All right, let me double check. Oh, yeah, localhost 5000. That's where the backend server is running. It is not working. Let's just log whenever we get a message. So get live chat ID, and then let's just log messages. Make sure we're actually getting messages from the backend. So the drop game is totally random. So if you do exclamation mark drop, it will drop a thing at a random X and Y velocity, and if it lands right here, you'll get on the leaderboard potentially. Direct center is a 100, further away is a lower score. And the leaderboard here resets for every live stream. Okay, so the chats are coming through. That's good. And then we have our on message. What does this do? If message doesn't start with that, well, did we change anything with the shift register? Data is 2, clock is 3, latch is 4. Okay. LED command, let's see if it makes it here. Breaking changes. See you later, Gatole. Thanks for hanging out with us. We'll see you later. We could do like a timeout, and we could basically like send a chat message, or you have to send a message where you join a specific team, and then we could rotate the players on the team. But yeah. Okay, so that it's not even making it that far. That's unfortunate. Join a team. Yeah. Line 95. Parts is equal to 0. So if parts.length is less than or equal to 1. Oh, yeah, so this should be less than or equal to 0. or equal to 0. Because parts is the thing that has the actual command inside of it. Yeah, that makes sense. And thanks for the follow, Swarov. Welcome. There we go. I built the drop game. It was absolutely inspired by InstaFluff, though. So you can check out Seedling Drop on GitHub. This is the one that I built. And if you search my YouTube channel, you can see the stream where I built it. So that's that. But InstaFluff created the original Penguin Drop. And this was basically a ripoff of that. But we made it coding garden themed with garden. So there's the code for the one that I made. And then here is Penguin Drop, which actually has changed because he made a totally new drop game. But yeah, there's Penguin Drop, and then there's just InstaFluffs, who's hosting someone else right now. But check out InstaFluff. He streams every Wednesday, Thursday, Friday. There you go. Hello, Evil Pisces. Good evening. I'm doing good. Yeah, I remember you doing that whenever we built the Twitch bot thingy, so it makes sense. Yeah. Hello, Faye. Welcome. Yeah, we could support other numbering systems like hex or even integers rather than 8 bits. But yeah. Cool. All right, we've been live for 47 minutes and we have not written any code really. Yeah. Yeah, so InstaFluff made the original game. And he has a game studio, Pixel Plush. Oh, not that. Pixel Plush Dev. And you can actually add Pixel Parachute, which is the latest drop game. You can add that to your own stream. If you go here, you can fill in your info, and then it'll give you a URL that you can embed. And hello, Clevy from Brazil. Welcome. You finally made it, Faye. Welcome. Thanks for the follow, Clevy. All right. How's the poll doing? Results. This is news. I don't know. Connect 4 game on the RGB LED Matrix. All right, let's do it. It's the winner. Let's. This is what we're gonna do right now. Okay. All right, let's make a directory. We're gonna call it connect 4 RGB LED. We'll say RGB Matrix connect 4. Open up VS Code here. We'll go ahead and npm init it. And then we're gonna need Johnny 5. So I'm gonna install Johnny-5. Like so. RGB matcon 4. Cool, so that's installing Johnny 5. But like I said, I have played around with this thing a little bit before, so I will show you where I got basically how to program this thing. Node pixel. Let's see. What's this called? Adafruit. What did we call this thing? NeoPixels. Johnny 5 NeoPixel. Here we go. This is a great blog post by Chris Ruppel that talks about using Johnny 5 to power NeoPixel. So these are a ripoff of the NeoPixels, but they work in exactly the same way. I don't know if it has the type of the thing on here. I forget what it's called, but it works in exactly the same way. Basically, what you need, and what's been created is this library called node.pixel. So node.pixel is a separate library that's been built specifically for programming these types of RGB LED matrices, or even RGB LED strips. They all use the same controller. So you can use Johnny 5 in conjunction with node.pixel, and then it's extremely easy. So you create a new strip, tell it what pin it's running on, and it only takes 1 pin to run. This is running on pin 13. And then when it's ready, you can set the entire strip to a color. And every time you set things, you have to call show for it to actually show up. Yeah. Yep, it does gamma correction for you. So they were saying 2.8 is the default value, but you can mess around with that if you want to, but it should just work. So there's that. Now, when I got this going the other day, Node Pixel actually had a bug for this particular type of Arduino that I'm using. So we may need to install a branch of it, but let's see. Let's just try to get it working. So the first thing is you use this interchange library to put a custom Fermata firmware on the Arduino. So I mentioned it earlier, but to use Johnny 5 with an Arduino, you need a special firmware. This interchange command helps you with flashing firmware to your Arduino without needing the Arduino IDE or anything like that. And Node Pixel specifically has a custom firmware that you can send to the Arduino that makes it really easy to power the NeoPixels. So, yeah, and this is it, WS2812. That's a really common thing for RGB LEDs. So this is what we need to do. Let's install Node Pixel in this directory. Right quick. If I choose to delete the branch via pull request, how do I update that to my local clone? Check out master, pull from my repo master. And you should be on the latest with the same commits. Yeah, there's a stream. If you just search for Coding Garden Twitch overlay game, you'll find it. You'll find it. And for a while during Christmas and New Year's, we had a Christmas drop game, and we built that one from scratch too. That was fun. Okay, so we installed Johnny 5. We're going to install Node Pixel. And then we're also going to install NodeBots Interchange. I'm not going to install it globally. I'm just going to install it in this same directory, and then we can use npx to try and install the firmware. So we're going to install that as well. And at this point, we have Johnny 5, Node Pixel, and we're about to get Node Interchange. So Node Interchange is that library for flashing firmware to this thing. Technically, you could just use the Arduino IDE, but it's a nice little package that does it all in one go. Okay. So I think at this point, I'm actually going to unplug my LED game, or the LED thing here, because we're gonna be working with a different Arduino. Technically, you can have multiple Arduinos plugged in. I don't have any extra USB ports, and when it flashes, it tries to detect the Arduino automatically. So we're gonna turn it on. We're gonna unplug it. Yeah, get your LED commands in. Should you delete your fork of a repo if your PR was accepted and merged into the original master branch? It's totally up to you. The fork will actually get out of date if you leave it and you don't sync it with the original master very often. So if you're not going to keep it up to date, you might just delete it. Some people like to leave forked repos on their GitHub profile to show that they've contributed to that library. So it's really up to you. Yeah, we'll see. But I believe you can. It's really fast. Spam the LED command. Okay, it's going now. These LEDs are only red. This is RGB. Every single one can be a totally different color. So that's what we're gonna do. Let's get this out of the way. New USB. Oh, and I'll basically show how this works. So here we have the Arduino. And actually, I'm going to pull up my... I'm going to be able to turn autofocus off. There's my camera. Advanced. Webcam control. Autofocus is off. Oh, I mean, that was actually a pretty good focus. Let's go about right there. And then can we still see? Yeah, that's great. That's a great focus. Great work. Okay, so, wait, I need to flip this, right? No. There we go. So this is our Arduino. It's an Arduino Uno R3. And you can see that it has all of these things here, which you can basically plug wires into. All of these are digital outputs, and all of these down here are analog inputs. Oh, and actually, no, these are just digital. They can be either inputs or outputs. General purpose input outputs. Yeah, so they can be inputs or outputs. Great. But this little shield is what they call this thing that I have. You can see that on top it looks almost like these things look almost exactly the same as the Arduino, because basically what they've done is they've wired up all of these RGB LEDs, and then they put these pins on here so we can plug this directly into the Arduino like that. It just plugs right in, and then it becomes a nice little hat on top of the Arduino. And what's cool about this is this is only using pin 13, so you can actually use the rest of the pins to program other things as well. So once you plug this thing in, you're not limited to just controlling the RGB LED. You could plug sensors in and other things like that. Also, you don't have to plug it directly into the Arduino. You could technically take a wire and plug up from power to power and ground to ground. Like I could take a wire, go from 5 volts here, plug it into 5 volts over here. I could take a wire that goes from the ground and plug it into the ground over here. And then I could take pin 13, which is what the one that's used to control it, and plug that into pin 13 over here, and we could program it just the same. But I'm going to plug it directly into the Arduino because it's going to be easier to work with. So let's do that. It's a great fit. And there we go. We now have our shield plugged directly into our Arduino. Let's get a better view on this thing. Oh, diffusion material? I don't. That's a great idea, though. I think what we're going to do is every single... Well, if we're making Connect 4, then we only need 2 colors. And we're going to default them to... Yeah, this freezes every time. But we'll default them to not bright colors, so we won't have to diffuse it. I guess technically I could put a piece of paper on it. Yep. So, and if you, yeah, it allows you to use the same number of pins. So if you look at the actual, the NeoPixels version of this, it doesn't have that by default. And I think you might need to do some of your own soldering. And yeah, you would basically have to solder your wires to be able to use those extra outputs. But the way this is configured is you can still use all those extra outputs. Okay. There we go. Cover that LED hat with I technically could. So I could basically take, because I have a second one, and because the way these pins are configured, well, actually, no, because they both would be plugged to pin 13. But yeah, I could technically just, like, put that right on top. I'm not going to, though. Let me see if I missed anything. Oh, push my bug fixes? Yeah, let me do that. Though, yeah, I will. I'm just kidding. It's not buggy code. Though technically it was. Okay, so we have this thing. That's great. Did I miss anything else? Come on, Chad. And thanks for the follow, Joel. Okay, so yeah, I'll accept that. The original code was hard to follow. So we have those dependencies installed. Now we need to flash the node pixel Fermata firmware to the Arduino. So I'm gonna plug the Arduino in now. So that the USB is not behaving. Let's do this. There we go. Blue tack to put it in place. Is that what that is? We need to flash the firmware. So this article was great and tells us how to do it. So we can install Node Pixel onto the Arduino. But what we're going to do, because we didn't install it globally, is we're going to do npx interchange install that. So it's going to download the firmware and then flash it to the board. It says flashing complete. That's great. Can this Arduino DDoS sites? I don't think so. And now let's just try to use his example program here. So over here in VS Code, we're going to create a new file. Let's call it index.js. Throw this code in here. And this is actually going to, if this works, it's going to light up very, very bright. I mean, technically, we don't have to predefine the strip. We can just do that. Okay, so we're bringing in Node Pixel. We're bringing in Johnny 5. We create a new instance of a board. When the board is ready, we create a new pixel strip. The thing I have to change here, though, is this particular board is run off of pin 13. I'm going to change that to 13. And then the length is 40, because there are 40 RGB LEDs on this thing. So we have that. Flashing direct from GitHub. It technically cloned the thing down and did all that. Cool. And now, so we create an instance of the strip. When the strip is ready, we tell it to be pink. Let's not do pink. Let's do blue. Red, green, blue. And the way the Node Pixel library works is you can set colors. You can also set individual pixels. This by default is going to set every single pixel to blue. And then when you say strip.show, it'll light up. Let's see if this works. I have a feeling it's not going to work, but if it does, that's great. So let's try it. We're just going to run this program. And it broke. So we get an error. Node Pixel Fermata controller requires I/O that can write out. And I fixed this the other day by using a branch of the Node Pixel library. So if we look up Node Pixel here, cycle through red, blue, and green to test. Yeah, we can do that. So this is the library, but there's currently an issue open, and there's actually a separate branch. Which one is it? Yeah, I think it's this J5 Fermata UPG. That fixes the issue, but it hasn't been merged or published to NPM yet. So we're gonna have to use a branch. We're gonna install a branch from GitHub and use that firmware instead. Where are we? Actually, I don't know if we have to change the firmware. We'll see. Okay. This error: Node Pixel Fermata controller requires I/O that can write out. I'm just gonna search this error on the issues here. Here we go. No writable port error. And people are mentioning, one, you could use Fermata version 1. I don't want to do that. And then this person is mentioning, use this particular branch. The J5 Fermata UPG. So what I can do, actually, is uninstall Node Pixel from this. So right now, I have Node Pixel as a dependency, and that's coming from NPM. But I want to use this specific branch on GitHub, which isn't on npm. So what I'm going to do is I'm going to say npm install, and then give it a link to that Git repo with that particular branch. So that's actually going to, we can watch it happen in the package JSON. It's going to change from being a version on npm to being actually being installed from that particular branch on GitHub. So now the node pixel library has that bug fix in it. Let's see if it works. I might have to flash the firmware again, but let's see. Whoa! It works! You can see that they're all blue. So that's great. Step 1, done. And I actually like what Doc is saying. Let's cycle through all the different colors. And an easy way to do that is with melting the camera. Yeah. But an easy way to do that is with HSL, because we can just cycle around the color wheel and keep the same saturation and light values. So I'm just going to search the web for HSL to RGB. Well, HSL to hex. Yeah, we could scroll a rainbow. Yeah, we could do a lot of cool things. But I want to find a library really quick. So the node pixel library actually supports hex color. So you can send any hex color you want to it. But what I'm going to do is, because I know how HSL works, I'm going to cycle through the HSL colors and then convert it to hex and then send that value to the strip. Yeah, you can see that I've looked at this Stack Overflow answer before. HSL to RGB. HSL to hex. This is the one. We're going to go with this one. Copy paste. Let's just put this right here. And while I'm thinking about it, I'm going to go ahead and install ESLint. Yeah, I can't go any further without ESLint. So let's make a source directory and put our index.js in there. And then I'm going to and actually, so the interesting thing is, if I exit, I believe, yeah, the board actually stays lit up because it still has power to it, which is cool. But you definitely couldn't be running animations on it and then leave the node.js program. But I'm going to install ESLint as a dev dependency. And Doc really likes this. Let's check it out. Oh. Could totally made a pull request that actually makes it so that I can just click links to copy them, but yeah. N plus h divided by 60 degrees, mod 6. Yeah. It's like a rave in here. Well, it's about to be. Once I get this library going, we're going to send all the colors in the world to it. Okay, ESLint is good to go. Let's set it up. Should we use the Airbnb style? Yeah, I guess we will. Rave parrot. Party parrot. Cool. So now take a quick stretch. Oh, I see. These are coming in as parameters, and then we're making sure that they're within 360. This is just complaining about no param reassign. We'll turn that off. It's lit! Yeah. In more ways than one. Yep, all that's good to go. And now we can call it. So here's what I'm going to do. In here, once the strip is ready, we're basically just going to cycle through all the colors and show them like every 500 milliseconds. So let's do this. RGB equals 1. Oh. It just doesn't like chaining assignment. I'm okay with chained assignment. I really just wanted my like formatting rules, but I always end up going full Airbnb style guide anyways. Okay, we fixed that. So let's do this. We're gonna create a for loop. It's gonna start. This is gonna be our H value in the HSL. So this is gonna be our hue. Our hue starts at 0, which is gonna be red, and we're gonna go all the way up to 360. And we're just gonna increment. We could increment by 1. Could also let's increment by 10. And then we can say const color equals HSL to hex. We'll pass in our H value, and then we'll just do a standard saturation of 100 and a light value of like 30. So we want it to actually be a pretty dim color. And really, before we even do this, let's we're gonna do it. This is what we're gonna do. And so we get back the hex color, and we're just gonna say strip.color, and then we'll say show. We do need to delay it though, because this will just all happen at once, and we want like, I don't know, half a second between each color change. So let's just do this. We'll do a set timeout. And the timeout is just going to be H times 500. So it's going to be 500 milliseconds between each color change. And this should work. You may have run into an issue before we were using set timeout inside of a for loop. This will actually work because I'm using let, which is block scoped. So let's go. Let's see what happens. Red-ish? Very, very red? Is it actually changing? I don't know. I should probably log when things are happening. Oh yeah, it's changing. It's now orange. Let's go faster than that. Let's go like 100 milliseconds. And then, yeah, let's go 100 milliseconds. So it should start off as, wait, there we go. Red, 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 red. Orange, 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 orange. Yellow, yellow, green. Green, 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 green. You can do 30 frames per second. Did it do it? 33.3. And let's actually, yeah, we'll just increment by 1. All right, let's go again. Actually, I might actually decrease the brightness. Look at that. That's a lot more dramatic. Haha, nice. That's cool. I like it. Okay, so it's working. We can set different colors. Make it a rainbow that changes column by column. We could do that too. Like we could build a, yeah. Is there a synchronous / callback version of set color? I don't think so. It's just, it is synchronous because strip.show will take all of the changes that you've applied and actually, that you've made and actually apply them to the board. So the other thing you can do is say strip.pixel and then pass in which pixel you want. So let's actually do this. Instead of cycling through the colors, let's cycle through all of the pixels. So we're just going to default to a nice red. We're going to go even lower brightness. And then we're going to go let I equal 0 while I is less than or equal to 40 because there are 40 LEDs on here. I plus equals 1. And we're going to say strip dot pixel at I dot color, and then we'll pass in that color. And we'll turn the pixel before it off at I-1. Can we turn it off? Maybe not. And this one we'll do every 100 milliseconds. Color to black. That would probably do it. I think I can also just do strip.off. So turn the whole thing off, set one individual pixel, and then call show. So this should set every pixel on here one at a time to red. Nothing happened. Cannot read property color of undefined. So, oh, not less than or equal to just less than. That's why. Because there are only 40 pixels. 40 LEDs. Did it work? Was it too fast? It might actually not be bright enough. I'm gonna change that back to 30. And let's see what happened. Oh, there we go. Wait, why is it blue? Everything's blue. It's not good. 0 is red, right? All right, let's just set the pixel before it. Color 0. And let's do 500 milliseconds. And really, we only want to do this, yeah, if I-1 is greater than 0. Greater than or equal to 0. Color doesn't accept red as a value. Well, I'm creating an HSL red here. Let's see. See if this works. It could be an issue that I was calling off too many times. There we go. It's not turning off the pixel before it, though. But it is lighting them up one at a time. Let's go with 20 brightness. Maybe we'll send the hex value? There we go. One at a time. We're working on this RGB LED matrix here. So we can program it. And now, honestly, we just have to implement the connect for logic. Great, we did it. Okay, so how is this gonna work? Let's just think up how chat will play. The lens flare is nice. Oh yeah, look at that. How to play. Okay, so should you have to join a team? Yeah, and the commands are actually going to be very easy because you just need to specify which column you want to drop your thing in. So a turn timer, yeah. Okay, let's say join a team. C4 join red or C4 join blue. All right, see you later, Pisces. Thanks for dropping by. So you can either join the red or the blue team. And then whenever it's red or blue's turn, anyone that's on that team can specify which column they want to drop it in. So your columns are 0 through 7. 0, 1, 2, 3, 4, 5, 6, 7, which makes 8. So you join a team and then make a play. And how will the plays work? I think we'll do connect for play, and then you just specify the for commands first in, first out, and it must be your team's turn whenever you go. Yeah, it's gonna be tricky because I don't exactly have a way of telling people whose turn it is. I mean, technically, we could use something like this and have the text on it. Honestly, it's not really a bad idea. Because we could say blue team's turn, and the next player on that team is the one that gets to send the command. I think for now, we're just going to make it super basic. We can always improve it later on. One team per stream. Yeah, so you can't change your team. You have to join a given team. I like that. But yeah, C4 play, and then you specify a column. So like 0. 0 through 8. Oh, flash the team's color. I like that. Wait for the board. Twitch versus YouTube? Yeah, I mean, we could make Twitch purple and YouTube red. What do you all think? Do you want to join your team, or do you want to make it Twitch versus YouTube? What do you think? Wait for a board to flash your colors, your team's color. Twitch versus YouTube. Oh yeah, 0 to 7. Thank you. Make it a competition. Twitch versus YouTube. Name of the pixel grid library. It's called node.js. And then this itself is like NeoPixels. But everyone's saying Twitch versus YouTube. Okay. You picked your team when you started the live stream. Yeah, the thing about that is someone could technically be watching on both Twitch and YouTube and playing on both teams. Oh well. Chat versus CJ. No, I gotta do a live stream. I can't be playing Connect 4 the whole time. All right, so that's great. Let's just, what do we do? We'll have like a game state. All right, it's all in my head. I know what we need to do. But first, honestly, we're just gonna, Alka went and made the code all complicated. Because this thing, the LED, the 8-bit LEDs, that has the code that's already talking to the backend, listening for messages. Honestly, it really isn't that complicated. And thanks for the follow, Lightcoon, and thanks for the YouTube sub, Waleed. But I kind of want to reuse the code that he's updated and written. Yeah. I mean, technically, it could listen for different commands and do different things. And actually, we could control the 8-bit and the shift register and the LED matrix at the same time. We just have to specify different pins. So this could work, because technically what we could do is plug our 8-bit game. Like, we can show both of these at the same time. I could do something like that. And use one Arduino to run both of them. Okay, so that's the plan. We're gonna reuse this existing code base. We'll need to install all those dependencies and such, but that's the plan. In 3D. Make a 3D printed board / webcam holder. That sounds awesome. I need that. I need that in my life. Okay. Do I really want to do this? Yeah. Okay. We're gonna modify the LED button, or the 8-bit LED thing instead of this. So let's get out of here. We'll close that. This is the 8-bit LED that's still running, but we're gonna kill it. And then we're gonna transfer over everything. So this is our README. We're going to go ahead and create a folder called source. We're going to move our index in there. And we're going to move in our types. And then we're going to create a new file called connect4.js. Throw this code in there. And then we need to install NodePixel. Yeah, I'm going to leave the code as is, but then we're just going to have connect4, which can like receive messages and it'll have game state and stuff like that. And then we'll probably have one file which manages all the incoming chats and then chooses which command to run. This is eventually going to get pretty complicated. Okay, so we copied that code. I think the only thing we need is the NodePixel dependency, this thing. If you do !VS Code, you can get a link to all my VS Code settings. All right, so if we do node source / connect4, that should cycle through the LEDs. It should still work, hopefully. Yeah, so that still works. Cool. So now that we're in the same code base, we can reuse all the logic for listening for new messages and things like that. So in our index, this is already connecting to the backend server and listening for messages. Let's see. Creating our register. On message. If command equals LED, then do the LED command. Else, if command name starts with C4, we're going to handle all of that in the connect4 file. So we'll say connect4 with the command. Oh, okay, yeah, that makes sense, Doc. I make useful commands. Okay, so basically all of this logic is what was running the 8-bit LED, and we're going to do similar things. So if it starts with C4, which is going to be all of our commands are C4 join or C4 play. Actually, no, C4 join is not a thing because Twitch versus YouTube. YouTube is red and Twitch is purple. Wait, are those going to be too close in color? We'll just make Twitch blue. Cool. And so connect4, yeah, I'll test it. Connect4 is going to be a function that we import into here that's going to handle all of the connect4 stuff. At the start of type command? Where's that? Oh. How does that work? Oh, okay. Yeah, cool. Awesome. So now we're just going to import connect 4 from that. Test. Hello, JJ Fats. Let's rename this file to connect4, like that. And yeah, the thing is, so this is waiting for the board to be ready and then creating a strip. I think what I want actually is to be able to pass the same board instance in. Yeah, so when the board is ready, we can call our, I want to call it like game manager or something. Yeah. Yeah? Yeah, no? Let's call this make move. All right. Our evil overlord. So instead, what it'll be when we get a message, it's actually going to be connect4 dot move, and then when the board is ready, we'll say connect4 dot ready with the board. Cool. That's cool. Is this Skyrim? Yeah. Is there Skyrim says, I enjoy these streams. It's a good break from working on my own projects. I appreciate that. Could you talk about the project? So we have this 8x5 RGB LED matrix, and we're going to make the game Connect 4 so that YouTube can play against Twitch. And we'll keep the camera on, and you all can play Connect 4 with each other. So this thing needs to export 2 functions. Yeah. Ready and move. So ready, we'll take in the board, and then do things with it, and then move takes in a command like this. And now we can move all of this code in here. So when the board is ready, we can do this. And right here, we just pass in the board instead. So we don't have to create a new instance of a board. And we're not really using Johnny 5 at all. We're just using Node Pixel. So when it's ready, create an instance of the strip. When the strip is ready, we'll cycle through the pixels, and then when a move command happens, we somehow need to get access to the same strip. But yeah. Hello, Wapti. Welcome. The stream is pausing? That's not good. Yeah, you can disable low latency. That might help. Yeah, let's disable this REPL. Hello, Bob. Welcome. And let's just log this connect4 move with the command. Cool. And because we have those handy dandy types, we can use them. So right here, yep, get the types there. And do we have a type for the board as well? Let's see. Oh no, it already has, I guess, the built-in types. Cool. Yeah, I think this should be good enough. So now when we start up this script, it's listening for chat messages. We have this separate module called connect4 that will connect to the strip. And then whenever we get a chat message, it should log here under the move command. Let's see. Yeah, so Johnny5 provides the types. That's good. So if anyone sends a command that starts with !C4, I should at least see it logged in the console. And right now, it's just cycling through the LEDs, which is perfectly fine. Yeah, C4. This is great. C4. It stands for connect 4. It's not an explosive. C3. Awesome. So basically we need to handle the different commands in here. Well, I guess there's only one command. It's just C4 play. Yeah, so actually, let's just, instead of if it begins with C4, we want it to be, or should the command just be a C4? Let's just make the command C4. That makes it easy. C4 column 8. I would just let you do C4 8. Yeah, just like that. That's what we'll do. I was differentiating the commands earlier because we wanted to like join teams, but it's just going to be Twitch versus YouTube. Hello, Aaron. Welcome. Yeah. Hello, Elia. Welcome. Hey. That's what we're trying to avoid that. Okay, cool. So, now that we have Connect 4, we need like a game state. I think we're going to handle all of that in here. Play against ourselves? Okay. Yeah, we kind of need to set board as a global variable in here. Just like let board. So the main thing is this ready function gets called with the Arduino board whenever it's ready, but the move command down here is going to need to use the board. No, actually, no, it won't. It'll just use the strip. Okay, never mind. We don't need a global board. We need a global strip. And initially, strip ready is false. And then when it is ready, we're going to say strip ready is true. Like that. And then we'll just set strip here. So that way, in our move command, so this gives us access to command.parts. So parts at 0 is going to give us the column. We can validate that it's an integer. It has to be 0 through 7. Is this a good way to do this? So, well, I mean, we could just, I don't want to do /d because it must be 0 through 7. And I want one digit 0 through 7. I could also do parse int. C4 table flip? Let's just get the commands coming through now. And we could do something super simple. So if someone sends a column command, we'll just light up a pixel in that column to be either red or blue, depending on if it was Twitch or YouTube. Should we just do parse int? Will this return nan if we get something weird? Yeah, with the regex, we know that it's a number 0 through 7. It will return nan for null, undefined, or false. Okay, so let's do this. We're just going to parse. We're going to match it, which would but could potentially return null. Let's see. Oh, cool. Yeah, so you can pass in an array of RGB, which avoids converting all the RGB values to a hex string. Cool. What visual display will there be for the winning team? We'll figure that out. I don't know. All right, so we have the column. I'm going to say if column is, well, can we do is nan? Returns a Boolean value that indicates whether a value is the reserved value nan, not a number. So if it's not nan, we'll do this, and the command dot platform will tell us where it's coming from. So we'll say if command dot platform is equal to Twitch, then we're going to light up that column as blue. Otherwise, it's coming from YouTube, and we'll light it up as red. So at this point, yeah, initially, let's get our two colors, but when the strip is ready, we set ready to true and just turn the whole strip of LEDs off. And then in here, we'll just say if strip ready, if strip is not ready, return. Like if someone sent a command and we're not ready to control the RGBs, do nothing. So that should be good. And then we need our two color values. Let's just put those as global variables as well. So we'll say YouTube color is that, and the Twitch color is, I don't know, what's a good hue value for Twitch? Yeah, well, so we were gonna blink the team color to say whose turn it is. So should we do like 240? 240. So here we should be able to say strip dot pixel 240 is very blue. Cool. We want pixel to be that particular column. And we want the color to be the Twitch color. Otherwise, we set it to be the YouTube color. All right, let's see if it works. So go 280. I can try that. You do need to specify a column. So C44 should turn purple, and it didn't. Let's see what I'm logging. C4 move 2. Oh, I have to call dot show. I totally forgot. You have to actually say strip dot show right here. Otherwise, it doesn't show up. And what Doc mentioned earlier is it basically flushes all the settings to the RGB, to the controller, anything that was queued up. So we definitely need to say show. And then Alka mentioned that the color should be 280. So let's change it to 280. All right. This is the winner. Oh yeah, I absolutely could put it outside the if statement, but it should start working. Yeah, so 6 is now blue. Three is blue. There's a red. Nice. Yeah, they're a little too similar because it's starting to look like purple because they're so close together. I might try the trick where I put a piece of paper over it to see what happens. Oh, let's do this. There we go. This is much simpler. Green doesn't represent either platform, but I'm going to create an object of colors that has the platform on it. So we'll just do this. We'll say colors is an object. Twitch has this color, and YouTube has this color. So now that we have, Twitch and YouTube, We're going to grab the color for that platform, and then choose that column and show it. Cool. What colors can we use instead? So let's look at that HSL thing. 0 is very red. We could do like, maybe like 180. Let's try 180 for Twitch to see if it's that much different. Could do yellow. We really just need like a stark contrast between the two colors. Otherwise they bleed. Yeah, so when it's ready, it turns everything off, and then you can start issuing commands again. Okay, so that's like a light blue. Lower the brightness, we could try that too. At some point, they won't really even light up. Somebody from YouTube, send a command. We need it to be red. There we go. I feel like you can differentiate that. All right. YouTube and Twitch, you need to work together. I want the colors to alternate. So I want column 1 Twitch, column 0 Twitch, column 1 YouTube, column 2 Twitch, column 3 YouTube. Alternate them back and forth. I want to see what it looks like when the colors are really close together. And yeah, I'm going to grab a piece of paper to see if that makes a difference. C41 on somebody on YouTube needs to set it. Spam. No, YouTube needs to be 1. It's 0 indexed. Oh well. I'll be right back. I'm gonna take a quick break. Feel free to keep playing around with this. I'm gonna grab a piece of paper to see if that makes a difference. And I will be back in, let's call it 7 minutes. Yeah, what do you all think right now? Should it be 0 indexed? We're programmers here. Should it be 0 indexed or should it be 1 indexed? In the chat right now, let me know. 0 indexed or 1 indexed? Zero indexed. 0 index is confusing. 0 index for sure. Okay, yeah, we're programmers. All right. So, real quick, Coding Garden with CJ is brought to you by viewers like you. Just a quick shout out to all of my patrons and YouTube members who support me. I could not do it without you all, so big shout out to them, and I will now show all their names on the screen. I'm going to take a 7-minute break. When I come back, we're going to implement the logic for this Connect 4 game, Twitch versus YouTube. Yeah, right now it's just the first row. we got it basically working. Now we have to actually implement the Connect 4 logic. Yeah, so the 8th column is 7. All right, see ya in 7 minutes. Hello. Hello, friends. We're back. Yep, the code's broke. We got to make sure that there's actually a command here. Let me hide the patrons. So, if there's nothing in it, return. There we go. Welcome back. Thank you. Thank you. Thank you. All right. I'll let you all play this. I'm going to cut a piece of paper to fit, and I'll also catch up to see if I missed anything. Just lots of connect 4 commands. Yeah, single digit. 1.5. Hopefully our parsing does it. RIP. Wait. I tried to tell him to I guess I didn't see your message about checking the link. Cool. Thank you, White Shark. This should not work, I don't think. Because we parse the command and check to see if it's equal to C4. What's up, Majestic Eye? Welcome. I don't have tracing paper. I just have a regular sheet of like printer paper. But let's try it. Ooh, that's nice. Yeah, it's not bad. I mean, it's kind of wonky looking. Let's cut it just right. Yeah, not bad. They are not warm, no. They're very cool to the touch. Guess I could use some tape to put it down. Yeah, so they're a low brightness. Just real quick, I'm gonna turn all the pixels on to see what it looks like when they're all lit up. So when the strip is ready, we'll just say strip.color. Colors.youtube. Strip.show. Paper burns at 230 degrees Celsius. Yeah, this is not good. Let's see real quick. I think I need to trim it slightly. The thing is, if I push it down, it's decent. It's usable. Well, let's call it usable. I can get some tape later to do that. But yeah, let's test it with blue. Take an iron to the pit. Yeah, it needs to be flattened. Write the index of the columns on the paper. Viable. This is definitely viable. Do I have a pen here? Yeah, it's good enough. I think I have some double-sided tape. I'll be right back, because I just don't like how like the bottom is very, very diffused. I'll be right back. Use the force. Use the 3D printer to weigh down the piece of paper. Oh, 3D print a piece of paper that goes over the Arduino and has a slot for a piece of paper. Yeah, we could do that. Right, how do I end it? So I have this removable poster tape, which is double-sided, but it might be too thick. Let's just see. The LED looks giant. The LED is this big. Tape it to the mat. Come on. Good evening, Mystery. Welcome. Oh yeah, the coding train collaboration was postponed. I think right now we scheduled it for the 26th. It could change again, but that's the plan right now, is the 26th. Why is this so hard? Hello, Nasruddin. Welcome. All right. Moment of truth. Hey, that's good. I like that. All right, we're going to stick with that. Let's code the darn thing. Oh, you're right. We could just put matte tape on it. No, it's good. It's good. Good enough for now. And thanks for the Twitch follow, Death Packs. What if your drop hits the target, then you choose a C4 column? Oh, so you have to hit the target to be able to make a move? That could be interesting. But what I just thought about is some people were mentioning it earlier. I do want to have a join and leave command. All right, no worries, Monster. Have a good night. Good luck on the essay. But basically, if you're in the chat, you can do !join or !leave, and then we'll only... I'm thinking we'll look for connect for commands to come from those individual people. And eventually we could hook this up, which will show whose turn it is next, either from YouTube or Twitch. But for now, I think anybody that's join or left... Alka says, I don't see a point in join or leave. Okay. So we'll just make it when it's Twitch's turn, the first person on Twitch to send the message makes the call. Yeah. We'll just do that. Okay. Well, back to what we're doing. When it starts up, turn everything off. And then I want to make it easy. So just to get it working. And then in the future, we'll have join and leave, but that means that the game will keep track of whose turn it is, and it'll cycle through all the players on any given team. But yeah. Yeah, we're absolutely going to animate the pieces dropping into place. Okay, so what we need is like a game state. And let's do that right here. Well, yeah, we'll just have game state. So initially, state? Assign the turns randomly so it isn't always the fastest person on a team. Yeah, but right now the way we're doing this is the YouTube versus Twitch. That's definitely not fair, but the people have decided that they want to do Twitch versus YouTube. Right now, it's actually not that. It says there are 30 people watching on Twitch and 50 watching on YouTube. So technically, YouTube would have the bigger team. But eventually, it'll cycle through a team. I don't know. We'll say current team. And this is going to either be Twitch or YouTube. So we have Twitch, we have YouTube. What I'm doing right now is just making this reusable, so I don't have to type Twitch and YouTube over and over again. And well, never mind. Let's just do this. Current team. We're gonna have Twitch, YouTube, and then we need to grab a random indice. Math.floor of math.random times 2 indexed into this. So the current team was going to be randomly assigned to either Twitch or YouTube. We then have the board, which I'm going to define in a separate variable. And this is going to be an array of all the pixels. And there are 8 pixels in 5 rows. So I will do 1, 2, 3, 4, 5, 6, 7, 8. Is that 7? 1, 2, 3, 4, 5, 6, 7, 8. And then we need 5 of those. 1, 2, 3, 4, 5. So the board starts off as totally empty. Like that. I'm not really taking full advantage of the RGB LEDs. The pieces could rapidly cycle through the rainbow. Team 1 is hue. Team 2 is hue plus 180. Wait, what? That's too complicated. Make it so that C4 also bans you for 10 minutes. We could do that. Tally all the commands during a turn and play the most sent command from that platform. Oh, I like that. So it could basically... there's like a 10-second window where it's waiting for commands from a given platform, and the one that has the most is the one that goes. I think we'll implement that. Eventually, it's going to be individual people's turns, but we're not going to implement that today. Let's take a quick stretch. And thanks for the follow, Shredliner. It could be an array of arrays. That would give us like XY coordinates, but the way this game is going to work, you're only ever sending a value 0 through 7. And the way the pixel library works is it's just 0 through 40. It doesn't have XY coordinates. So this is pixel 0, and then this one all the way on the end is pixel 40. So that's how we'll do it. Hey, Sharpie360, what's up? Nani? Okay. Yeah, so we have the current team, the board. What else do we need on the game state? I could do this. I absolutely could, but I like the fact that this is like a physical representation of the physical, like this is a software representation of the physical board. I know that I can do that. I know that I can do that. But this will allow us to test things by like changing the board state. Okay. Memory is one-dimensional. You're absolutely right, Doc. You tell him. You tell him. Okay, so we have our board. When someone makes a move, let's make the drop animation. Let's make it actually fall onto the board. So let's do this. If it's not nan, and oh, is active. I like that. So like waiting, almost like waiting for play. Something like this. So like we're waiting for the next team to, or someone on that team to send a command. Make the team guess a number between 0 and length of platform viewers. Might make it a little more even between Twitch and YouTube. The games are going to be quick, so I'm totally fine with it just choosing a random person to start. Let's just get this working. We need to get this working. So choose a random team to start. Waiting for someone to play is true, and then we have the initial board state. So when we receive a command, if it's a valid column, playing... if it's a valid column and command.platform is equal to gamestate.current team, then that means the team. So right now we're just gonna be. It's just gonna be the first person to send the command. So or gamestate waiting for play. So if we're not waiting for a play, don't allow people to send commands. We're doing that. And then if someone sent a command, we want to make sure that they are the current team that should be able to play. And then they'll do that. So connect for move on that column, on that platform. And then we'll also include command.author.display name. Okay. We're going to grab that team's color, and then we're going to do this. Let's just say gamestate dot board at that column equals that color. And then we'll have a function that iterates over the board to update all the commands. So then we'll say update matrix, something like that. And then this just needs to iterate over every pixel on the board. Have a dot of the team's color scroll across the top when it's that team's. I like that. It could be going back and forth, and then whenever they send a command, it stops and drops. I like that. I like, instead of flashing the whole board, it's just it's scrolling across the top. I like that. Okay, but we can just say gamestate.board.for each pixel, and we're gonna grab the pixel and the index. Because then we can say strip.pixel at that index dot color will be that, well, let's call it color. And then we'll do strip.show. Do this. Say waiting for play is now false because they just made a play, and then update the matrix. Okay, so what this should do, and let me just log to the console who's going to be the first team to play. Okay, so it should turn all the LEDs off. It broke. Assignment to a constant variable. Line 52. Oh yeah, I don't need to do that anymore. What was going on there? Okay, so Twitch is the first team to play. So the first person on Twitch to send a command, it should light up that column. And that should be the only column lit up. So yeah, now column 4 is lit up. And then if Twitch sends more commands, or even YouTube, nothing should light up because now we need to animate it to fall into place. Yeah, so nothing else should light up. And now we can animate it to fall to the bottom. All right. 40. So you can only send a value 0 through 7. Great. Now we update the matrix. We could also we need a function that will animate the pixel to fall to the bottom. Let's call it animate matrix. And so what we need to do is we need to look at all of the pixels on the board, and if they're dangling, right? If they are not touching either the bottom or some other pixel, then we need to move it down 1. So Doc is saying animate row by row. If a column has space below a piece, move it down 1 and repeat. Otherwise, animation done. Yes, that is much better said than what I just said, but that's the plan. So basically, we look over the matrix. If there is a pixel that has something empty below it, it needs to move down to the next one. So I think I would rather do this in a probably in a for loop. So yeah, and I guess we could go row by row. So let I equal, let's say row equals 0, while row is less than 5. And then we'll iterate over the columns too. Columns are from 0 to 7. And lucky number 7 with the raid. Welcome, everyone. Welcome to the show. You have arrived at the coding garden. And we are currently programming this LED matrix. This is similar to what we're programming that's down there. And we're creating a Connect 4 game where Twitch can play against YouTube. So I'm streaming on both Twitch and YouTube right now. And you'll be able to play the game in the chat. So when it's Twitch's turn, anybody from Twitch can choose a column to put a Connect 4 pixel on, and then whoever wins, that team wins, and then the game starts over again. But right now what we're working on is getting that pixel animating down to the bottom. We got it working so that the commands come through and the pixel lights up. But yeah, Doc has a great thing. So pixel, row, column. Can you pass in 2 things to strip.pixel? Twitch finished Pokemon and Dark Souls. Oh, on the Twitch plays? Yeah. And thanks for the raid again, lucky number 7. What were you working on today? Oh, pseudocode. Yeah, so really the part that I need is this. I mean, really the 8 times row plus column. And we can say, like, if board at that index is has a value and any one of its and it's in the neighbor below it doesn't, then it needs to move down. Pseudo off through Discord DMs to Twitch. Interesting. Interesting. Hey, no worries. Thanks for the raid. Thanks for dropping by. And thanks for the follow, Crank. Okay, so if board at index, so that's going to give us the current row that we're on, and we want to look at the next row. And so that's just going to be this same calculation, but we're going to have row plus 1. And really, we only want to go up to row 4, because row 5 we don't care about. If row 5 is already lit up, it just stays there, like that. So if board at index does not equal 0, meaning it actually is lit up, and board at the next index is equal to 0, then that means we need to move it down 1. And I want to animate each of these moves. So maybe if a move needs to happen, we push that move into here. So let's say moves is an array. We'll say moves.push, or excuse me, it's really like the next state of the board. And I guess technically we can just, maybe we store the number of moves. Like if a move happened, then we need to set, yeah. So let moves equal 0. So if a move happened, then we're gonna have to do it again to keep animating. But at this point, we can say strip.pixel at that given index is now going to be set to 0 because we need to turn it off, and we want to turn the next one on. So the next index is going to be board at that index. So get the current color here and put it on the pixel right below it. So that'll do that. And we're just doing one at a time because we're not modifying the board, right? And then this was one move. Should I modify? No, let's. I think let's do this. Let's put this in a function that's just like show board, and this does the job of iterating over every pixel and setting it. And in here we'll just modify the board. So we'll say board at index, board at next index equals board at index, and board at index equals 0. So now we have the next state. The issue here though is yeah, so we definitely want to do the moves, but what I'm worried about is now that we keep iterating, it's going to move that pixel down without animating. So I think actually we want to break, so increase the moves, break because we have one move that needs to be made, and yeah, I think this is what we want. And we'll say if moves is greater than 0, break here as well, and then we can say show the board, and if moves is greater than 0, we'll do that set timeout. So in, let's call it 1 second, animate the matrix again. I think this will do it. Let's catch up on the chat. There's a lot going on. And thanks for the follow, Xgaben. Thanks for the follow, Coach Dench. Thanks for the follow, Crank. I think I said that. Set timeout, move pixel down, timeout until it comes to a rest. Yeah. So an animation occurred, and honestly, this is okay for the Connect 4 game because there's only ever going to be one pixel moving at a time. So if I know that this pixel needs to move, I can just break out and not continue iterating. Because the issue here is if I go down to the next row, it would keep moving it down to the bottom without a chance to actually animate the board, which is why I'm doing this break. There might be a better way to do it, but that's what I think. And then, yeah, my chroma key is blue, yeah. Because this is the coding garden, so we have a lot of green things here. Can someone help me close my 45 Chrome tabs? Use an extension called OneTab. Multiple falling blocks at once. Not for this game. This actually makes it very simple, which is why I can do this logic. For ones where multiple are falling, we would need like a next state instead of modifying the existing state. But yeah. And hello, Dana Chu. Welcome. Yeah, and for that, absolutely. For this, I don't think we need to. I think if I run this, it's going to drop to the bottom. Let's try it. Who thinks this is going to work first try? Yes. Yes? One in the chat if you think it's going to work first try. Not a chance. Okay, we'll see. It will work. So YouTube gets to play first. So the first person on YouTube to do a play, we might see that one drop. Let's see. Let's see. Nobody believes in me. So you need to do exclamation mark C4 space and then the column you want to do. All right, we broke it. Board is not defined. Yeah, that makes sense. This needs to be. We'll do this. It didn't work. It technically didn't work. Grab the board from the game state. Yeah, board there. So this will animate the matrix. Oh, and I think we should probably call show board. Should we call show board first? I don't know. Let's see what happens. I have a feeling it's going to skip the very first row. We read the code, so we knew it wouldn't work, right? It looks like the first now we need a command from Twitch. So Twitch is the first team to play. Nice. It's not turning off the previous pixel, so we need to fix that. It did, yeah. So it skipped the first row, and then it didn't turn off the previous ones. Yeah, so we got a couple things to fix. So the fact that it skipped the first row means that we're not showing the board before animating the matrix. So I think what we'll do here is we'll say show board as it is right now, because we're setting that specific column. And then we'll start animating it after 1 second. And then the fact that it didn't turn off worries me. It could be that setting it to 0 doesn't actually do anything. Let's see. If color is equal to 0, do we need to like literally set it to a hex black? Let's try that. All right, YouTube's up first. Some mofongo with fried meat. I don't know what fried meat is. I don't think I can off a pixel. I'll look at the node pixel docs, which I should have done. Hey! Nice! Nice! We have the beginnings of a Connect 4 game. That's not bad. One tab is, I love one tab. Yeah, hey Mary Jo. Woo, yeah. Okay. So here's what we can do. Off is available. Okay, let's do that. So pixel dot off. Like that. Cool. This is awesome. Okay, so we'll do it until there's no more moves left. Else, we just switch it to the next team. So otherwise, we'll say waiting for play is true, and the current team is the other team. So and we'll say if game state dot current team is equal to Twitch, then game state dot current team is YouTube. Otherwise, we'll set it to Twitch. So waiting for play, and also the place to check for a Connect 4. Yeah. We'll get there. not quite yet, but what this should allow us to do is to like stack pixels. So let's do it. And actually, I'll log waiting for play from. All right. Cool. And so the way this is going to work, it's just going to bounce back and forth between Twitch and YouTube. So Twitch can send a command first. So it will wait for that one to drop. Now YouTube can send a command. And you can send it anywhere. And you should test it on column index 1 to see if it drops on top. Yeah, so now whenever it's Twitch's turn, try going on top of either of those pixels. So it's Twitch's turn. Here we go, Doc. Nice! Yeah, and so that one should land there. Cool. Now it's Twitch's turn. This is fun. All right, YouTube's turn. And right now I'm not queuing up commands. I technically could queue up all of the commands that came in from YouTube or from any platform when it was that. All right, it's YouTube's turn. You need to block Twitch. Oh no! Twitch, you could take the win right now. There we go. Twitch with the Connect 4 win. Awesome. Okay, this is great. Now we actually need the logic to check to see if yeah, we need, okay, let me write out my thoughts because there's a couple things we need to do. For one, we should not allow people to play in a column that's full. Yeah. A cheesy win animation. Yep. What happens if the column is already full? Yeah, so we need to handle that, Nessie. That's what I was just mentioning. And actually, let's see what this looks like without the paper on it. Oh, that's not visible at all. Okay, never mind. Okay, yes, let me write my thoughts down. What do we need to do? Do not allow a play on a full column. The other thing is check for a winner. The other thing is a cheesy winner animation. And then the other thing is indicator of which team's turn it is. I will eventually. Right now, I want to see it in the chat just so I know what's happening. But I will block that so it doesn't pop up eventually. Yeah. Okay. For an easy one is do not allow a play in a full column. So we can also do this. So I think we won't skip the team. If they make an invalid move, we just won't allow the move. Yeah, so basically that's what we're going to do right here is check if it's full. So, and GameState.board at the column does not equal to 0. So, if it's equal to 0, well, if it's not equal to 0, then that means there's something in that column, like the blue pixel up at the top there. So that will just skip that. Easy enough. That should fix that. We then need to check for a winner. That's going to be hard, isn't it? So we need to look at every pixel to see if it is in a winning row or a winning column or a winning diagonal on every single pixel. Okay. 7 is stuck. All right, let's see what happened. 7 didn't animate down. Oh, it could be my column logic. Oh yeah, how about that? So how about when it's blue's turn, all of the blue lights on the board are blinking, and when it's red's turn, all of the red lights are blinking. Checking for a connect for a win condition is like a coding interview question. Yeah, I think I can do it. Yeah, I think any pixel that's on the screen is currently blinking, and then at the beginning of the game, when there is nothing played, we can just flash the entire board. Hello, Noel. Welcome. Okay, something's off with, I think we're just gonna blink. Something is off with column number 7, and it could be, oh. This needs to be 8. And row, yeah, I messed that up. Unexpected token function. What? Oh. Check for win. All right. It should reset the board. Now, everyone just try putting stuff in column 7. Make sure column 7 still works. Twitch goes first. I think I messed up. So, if... Oh, and the game is equal to 0. I broke it. not equal, is equal. There we go. Try again. And... YouTube is first. Oh, there we go. Right on time. Okay, let's write our check if there's a win function. So I kind of like this that said, like, get index. This is a little function that takes in the row and the column. Let's just do this. We're going to create a function called get index. Takes in the row and the column and just returns 8 times row plus column. Like that. And then we're going to have another for loop that looks over every single cowboy dab, cardboard cowboy dab. We're going to look at every single pixel, and then we need to see if that pixel is in a winning row. There's probably an optimized way to do this, but here we go. And let's actually reuse this getIndex function. Put that up here. And then we can use it right here. Like that. Should be good. Noel says, I feel like you should remove the commands, the more games project. Yeah, we'll do that. Right now, I'm going to keep the connect 4 commands just so we can debug things while they're happening. Okay, so we're gonna look at each individual index to see if that thing is in a winning row. And so we need to get all of its neighbors. So Nicholas says, don't you want to save who sent it each move for later points accumulation? Yeah, absolutely. So right now we're just logging it. We can see which player did what. But yeah, eventually we'll have a leaderboard. We also will have, you can join a team and then it will be one specific person's on the team's turn rather than anyone on the team can play. And we'll probably get this thing involved where we can show this and it'll say like who the current player is and whose turn it is. But yeah. All right. So we have an index. We want to check. Let's first check and see if this is a vertical win. Has win. It's false. So if this is a vertical win at that index, we're going to immediately break out and we're going to return has win like that. And I guess technically I could just return true right here. Let's do that. Else if is is horizontal win. At that index, we'll return true. Else if is and then there's two different diagonals we need to worry about. We need to worry about this diagonal and potentially this diagonal. But yeah. What do we call that? A right versus left diagonal? Has win is greater than has won. What do I call that? A forward diagonal and a backwards diagonal? Yeah, there we go. Alka has it. Is forward diagonal win at that index. Is backward diagonal win at that index. Okay, and ideally, I mean, so this is going to start in the top left pixel, and if it finds a win, it's immediately going to stop. So that's nice. Okay. Put that in a chained or it will short circuit on a win. I do want it to short circuit. Yeah, I do want it to, because if it's going, I'm going to write these functions to look at the neighboring cells. And if the neighboring cells have the same color, I could do an OR. That makes sense. We'll do an OR. I still have to write these functions, and I don't really know how I'm going to do that, but I'm going to try. Wait, what's happening? One tab is not good. Well, that's okay. I have blue switches. It's a cheap mechanical keyboard, but they are blue switches. Someone's calling. Yeah, I've never heard that before, but it's definitely possible. Oh, yeah. That's a great animation, Alka. This was what I had in mind initially, but if there are plays across the top, it could be confusing. Because then you don't know. Well, I guess if there's plays across the top. Oh, no. That's why I think I don't want to do this, because if there are plays on the top row, then I could set it to a lower brightness. I'm gonna flash the LEDs. To me, that seems the easiest, is to flash the LEDs. Because I'm mainly worried about, like, if it's somebody's turn to play and they don't know what colors have been played on the top row, they can't really make an informed play. And or is it value left or right, just like sequential ifs? Yeah, it's the same thing. Like, it's the same logic. It looks nicer. Okay, let's implement is vertical win. Though I guess I'm trying to think. So what my initial thought was, I was going to choose a pixel starting at the top left and see if that's a vertical win. Meaning if all of the things below it or above it are count up to 4. And if not, we move on to the next pixel. But what I could do is, like, scan the entire board to see if any column of 4 is filled in. That honestly makes a little bit more sense. This is absolutely an interview question. Has anybody ever gotten this interview question? Detecting if there's a win on a Connect 4 board? Scan the entire board, and for the diagonals, you only need to check the top 2 rows. 4. You're right. Beautiful. Okay, that's what we're gonna do. So we're actually just gonna reverse our logic. We're gonna do this. We're gonna just return, and we're not gonna pass in an index. An interview question asking you to build this in 30 minutes? It's probably possible. I'm not that confident right now. I'm a little bit baffled, but we'll figure it out. Okay, so vertical win is just going to check all the verticals. Whether you can check the entire board using bitwise operations. That's funny, Alka. We only need to check where the new move landed, not the whole board. I guess that's true. I kind of just thought I was going to brute force it, though. No, that makes it a lot simpler, though. Yeah, so what we could do is, where that pixel was just played. So let's put the last... It's easier to check the entire board for a win condition rather than the new move. There's a few subtleties with the latter. Okay, I'm gonna go with Doc. I'm sorry, Cheddar. I'm gonna go with Doc. Yeah, and thanks for the follow, Lowered Orbit. All right, let's try to make this happen. So for vertical wins, we really just need to iterate over the columns. No. Yeah, we're gonna iterate over the columns. Happy birthday, Minaj. Birthday emotes and emojis in the chat for Minaj. This is more like tic-tac-toe logic. It kind of is, yeah. Okay, so here's what I'm thinking. We're going to iterate over each column. And I guess actually we'll put the... iterate over the rows too. But when we scale our board to 600 by 600, it will slow down. I don't think it will. We're going to check the whole board. We've gone down this path. Okay. So we're going to iterate over each column. And then for each column, we want to see if there are 4 colors that are the same color in that given column. So really, it's either the top 4 or the bottom 4. That's your only option. You can't have any in between. It's a very simple board. So we kind of, I want to make an array of all of the pixels on any given vertical. So is when initially is false. We'll just create like a for loop that goes from 0 all the way up to 4. And we want to check to see if they're all the same color. And really, we can just look at the top one to see if it has a value and the bottom one. So we'll say if game state.board, let's destructure it. So if board at our index is going to be this column with row 0. So if board at that index is not equal to 0, then we're going to do this check. Cool. And then here we're going to do another check. And we want the very bottom one. We want to make sure that we're going to see if the bottom row is turned on. Because if the top one isn't turned on or the bottom one isn't turned on, it couldn't be a vertical connect 4 because there's only 3 that could be lit up. This is required, and it is a constant. It's not growing, and it's not based on the input. But yeah, nested for loop. But I'll say the next index I want. Let's do this. The next index I want is in row 4, column, whatever column I'm in. 0, 1, 2, 3, 4. Yeah. And if that is not equal to 0, then we'll check that one. And really, I'm only going to iterate up from 1, because we're going to say let winning color equal board at that index. And we'll say if board, well, let's get a new index in here. Let's actually just rename this to row. No. We'll say if board at index does not equal winning color, then we'll break. But if we made it through that whole for loop, then we'll say is when equals true. Take a quick stretch. Yeah, this logic is gonna get messy. All right, I need to get this going though. So we'll say is when is false. If we're gonna pick the first color on the top row as the winning color and make sure that the next 4 are equal to that same color. Because if any one of them is not equal to that winning color, then it's not a win. But if every single one was the same as the winning color, then it was a win. And then here, actually, I can just return true. Let's do this. We can just break out. return true. And if it gets through all this, we're going to return false. It's not a win. And then we really just need to do this exact same logic. But the winning color starts at the bottom. And we're going to go from 1 up to 5. Yeah, so this is going to be the bottom row color. And then we want to go from from 1 up to 5. Wait, this should have gone from 0. Never mind. Now this goes from 2 to 5. 0, 1. No. 2. This goes from 1. Goes from 1 to 4 again. This is the exact same logic. For each column, just count the length of the continuous color blocks. If you encounter a block greater than or equal to 4, win found. I'm going to continue down the path I'm going, because a lot of code. Winning color start. We're picking the one at the bottom. And we're going to go from 1. Really, it only needs to go up to 4. And this one, because I was checking it at the top, that needs to just go from 1 to 3. 0, 1, 2, 3. Wait, same thing. Never mind. It's exactly the same. The only difference is we're comparing it to either the last one or the top one. Yeah. Hello, Splart. Welcome. Z says, your JS skills are admirable. Learning over here. Or admirable. Admirable? I don't know. Thank you. Modulo 7 or mod 9 for diagonals. Okay. This is getting real complex. Good luck changing. Yeah, that's what Cheddar said earlier. We could technically look at the play that just happened, because then we only have to look at the things around it. This is fine. This part right here, we can put into a function. Admirable. Refactor. Oh, well, this. Refactor. We have a function, is winning column, that starts at a given index and a given column. So we're checking either the top or the bottom. We can grab the board here too. There's more edge cases to play with a single play, because you have to check upwards diagonals as well. This is true. Okay. I needed to just code this thing. So we're figuring out the index beforehand, which is going to be either the top or the bottom. If that thing is not equal to 0, then that means it has a play in it, and we're going to compare everything else to it. Great. And then we do the exact same thing, but with the bottom row instead. This checks for vertical wins. Yeah, we should probably write some tests. What I could do is I could start off. Let's do this. We're gonna start off the game in a winning state and then check to see if there's a win. So we're just gonna check this very first column. Let's set this to be a win. We're gonna do colors.twitch. Colors.twitch. Well, let's do this. And then when the thing starts up, YouTube should win. It's just a test. We'll go to, what did I call this function? Show board. And then we'll just log is win. I think I had check for win. No, actually, we'll just, we're gonna just check is vertical win. And I guess technically is vertical win should return the winning color or the winning platform. Yeah, this returns the winning color. Yeah, this'll work. So it should at least light up 4 in the middle, and it broke. Board is not defined. That makes sense. We need this. Is win, and then Twitch lights up. It's working. And then the other thing to check is if it's a win in the other way. So if we go, this is YouTube, and then this top one is Twitch. Yeah, and so it detects that as a win as well. Can anyone poke any holes in my logic? This should work, right? You haven't really been able to use Twitch Prime before. You can support me on Patreon or as a YouTube member, but I don't have any monetization on Twitch right now. And hello, it's me. Hole. This works. My logic is sound, right? Right? All right, so we have winning column. No, vertical win. We now need to check for horizontal win. And let me examine this thing. Oh, and thank you, Shaggy. Thanks for the link. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. There are a lot of combinations of wins for the horizontals. A lot more than horizontal win. Find and replace row with column. Really? Let's see. Row. So row equals 0. We want to go, we're going to look at all 5 rows. Maybe not that easy. And then No, because we need to check 4 in a row all the way from 0, 4. So 0, 1, 2, 3, 4. All the way up to 4. I actually do need to iterate here. So column equals 0, and we're going to go all the way up to column 0, 1, 2, 3, 4. So 5, technically? 0, 1, 2, 3, 4. Yeah, so 5. Because I don't know the best way to illustrate this. I guess I can just point at this. Well, here, I'll do this because to me it's just easier to look at. So this is what I'm thinking. If we're checking for horizontal winds, we really only have to look at the 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4. So we can check the next 4 starting from the left all the way up to column 5. So we basically need to just iterate from, we're going to look at every single row, but we're going to start at column 0 and go up to column 5. And for each of those columns, we're going to check to see if the next 3 are the same color. So it's going to be very similar. Let's move this out the way. And you're more than welcome to keep sending commands because they should actually light up. Yeah, so we're not going to do edge wrapping. We just start at 0, we go up to 4, we're done. And then I think get index takes row and then column. Is winning row? Starting at that index for that given row. And if it is, we return that color. Now we need an isWinningRow function. Takes in the index and the row. It's going to be very similar to isWinningColumn. We're going to... Yeah, so we take in the row, and we want to iterate columns. Wait. Yeah. No, we need to pass in the column here. Is if pixel at row, check next column at pixel +1. If it exists, keep going, else false, then reverse for backwards. Yep, that's what we're going to do, but we can just go from 0 to 5 and check everything after it to see if it's a win. But we do short circuit it. Just trying to see. So the index is the start, and then we actually, I think we care about where we're starting on the column. Yeah, because index is the starting index, and then we actually care about the starting column. I think I need row and column in here. I'm going to do this a little bit differently. This is the start column. And this is the row that we're in. Okay. So isWinningRow takes in the row and the start column. So we'll say if and then we need to grab the index. The starting, basically the starting index and the starting color. Because we're going to look at that starting pixel. We're going to check to see if it is not equal to 0, because if it's not, then it's a color and we care about it. So the winning color is that. And then we want to look at our columns. So we're going to say column is equal to start column, while column is less than 4. No, is less than start column plus 4. Grab the index. If it's not that, we return false. Otherwise, we return true. That's it. That's the winner. Some sweet recursion would be nice here. I don't know. I'm not feeling that smart today. I don't know. Yep, that's what I'm doing here, Acid Spark. So we start at the start column, which in, like, let's say we start at 0, and then we need to check the next 4 columns to make sure that they're all the same color. And is it start column plus 4? So if we start at 0 and go to 0, 1, 2, so that would go to 4. So we would look at there's only one way to test it. That's how we're going to test it. So let's just check a horizontal win. If you do ! VS Code, you'll get a link to all my VS Code settings. Hello, Coding Room. Welcome. How to build an app with Python. Check out Brad Traversy. He has some good Python videos. You missed a lot. We've been live for 2 hours, 15 minutes. So we're now gonna have a, well, I mean, technically this doesn't make sense. Here, let's put it at the bottom. Because let's say that Twitch is lined up across the bottom. And then this should tell us that there is a winning, so is horizontal win. Here we go. Start column is not defined. Where did that happen? Oh. Just column. Seem very I'm like I mentioned earlier, I'm not feeling confident today. Get index column is not defined. I think that's in here. Yeah, I called it call instead of column. This should be named call. Really, it's the current column. Assignment to a constant variable. We'll get this. We're gonna get there. This is it. Here we go. It's gonna light up across the bottom. There we go. And it is a win for Twitch. This should work, right? Does anybody see holes in my logic? Who's tired of watching me now? And because I'm not taking anyone's suggestions and just like writing really weird and convoluted code. All right, let's test like a few other areas to make sure that that would work. Check the other. Yeah, we're gonna check the other side. That's a good plan. Well, thank you, user. So this should light up the other half, and it is still a win. All right, let's check in the middle, maybe. Yeah, I think I've done it. We have vertical and horizontal wins. Let's just play a game. Here, let's get a game going. We're not going to check for diagonal wins, but we are going to check for horizontal and vertical wins. The white paper was not my idea. That was Doc's idea to like diffuse it. Okay, so Right now, we don't have any checks for diagonal, but we can check vertical and horizontal. Diagonal win. Okay. We'll keep that in a second. But we can play a quick game where only horizontal or vertical wins. So we have this check for win function that can do either vertical or horizontal. We do right here. Right here is where we want to check for a win. We can has cheeseburger. And so we'll say if winner, do the thing, else it's the next player's turn. We probably also need to check and see if all of the pixels have been taken up, because if all of the pixels have been taken up, then the game is over. Winner. And then we're gonna log just winner, which should be a color. We're gonna have to convert it eventually, but that's okay. Let's just do that really quick. So basically we need teams by color, which is the opposite. So we'll say we can use a computed property here. Let's say colors.twitch is Twitch. And then colors.youtube is YouTube. Yeah, colors at winning color. Wait, do I have a colors variable already? No, teams. Teams at the winning color. Virtual assistant. If winner, you win. Else loser. That's basically, well, right now, if you win, we're just gonna log you're a winner. If move count equals 40, board full. Universe broken. Yeah. All right. We're not gonna handle that, but I'm gonna reset it, and you all can play together for horizontal and vertical wins. Here we go. It should reset to nothing. All right. Twitch is up first. There we go. Daniel Garden with the column 1 play. It's now YouTube's turn. Inspirilli with the column 5 play. All right. Now it's Twitch's turn. And the way it's working right now is the first person from that platform to send a message, that's the one that wins. In the future, we want to have like a queue where it'll actually be someone's turn, like on YouTube or on Twitch, but yeah. All right, Alka with the column 1 play. Somebody should probably stop that from YouTube. Does everyone know how to play Connect 4? That was not a good play. Hot doggo. That was not a good play. Yeah. So right now we need to stop Twitch or Twitch is gonna win. Twitch is gonna win. What are you thinking? All right, Twitch, an easy win. Here we go. Winner, Twitch. Good game, everyone. All right, let's play again, but appease me, everyone. Try to get a horizontal win instead of a vertical win, and we'll make sure that works too. I realize there are better ways to test things, but this is fun. All right, YouTube, you're up first. Oh, I like that. If that team wins, then the whole board turns that color. Oh, nobody knows about Connect 4 in India? The point of Connect 4 is to get 4 of your color either horizontally or vertically or diagonally. Right now, I only have horizontal and vertical winning implemented. Yeah, let's get a horizontal win, though. Just choose a column that hasn't been played yet. Let's try to get a horizontal win. Well, Twitch is gonna win before YouTube. YouTube, you're not very good at this game, YouTube. Oh, wrong block. Oh, bad play. It's YouTube's turn. You can stop them. You can stop them from winning right now, YouTube. Yes! Great work, Kamal. You stopped them from winning. But actually, we do want a horizontal win, so if you would let YouTube win, that would be great. No mercy. Come on, YouTube. One more. You want 2. You want column 2. There we go, Chad. Oh no, it's Twitch's turn, though. Twitch could... Okay, Twitch didn't steal it. You need column 2. There's so much happening. Yeah, there is a diagonal win. I don't have that implemented yet. Alright, YouTube wins. Okay. You won the diagonal, that's true. But I haven't implemented that yet. Connect 5. That's actually a really good Connect 4 strategy, is if you get 5 instead of 4, because like you were winning from 2 different directions. But yeah. Cool. So that's awesome. I think what we can do really quick is attempt to implement diagonal winning. I don't know how hard that's going to be. It sounds complex. Yeah, so basically the way the game works is the first team to connect 4 of their own color wins. And it's actually a physical game where you like drop a little like checkers chip in the top and it goes down. Actually, I should pull up some pictures, honestly. Let me do. And actually, let's just do this really quick. Whoever wins, we'll just say strip dot color so if there's a winner, it's just gonna turn that color. Okay, but let's look for images of Connect 4. Tic-tac-toe, but bigger. Yeah, this is it. So it's like a physical kids game. You drop the checkers in from the top. The first one to connect 4 of their color wins the game. So that's what we're building. We're just using an LED, and you're playing over Twitch. Yeah, and reset after 5 seconds. Yeah, let's do that. My network is slow tonight? Really? Oh, no. I added an image proxy. Yeah, so the images are loading through a proxy now, so that could be why. Yeah, the image proxy is slow, for sure. So this creates a new game. No, let's just say let game state equal new game. And then when there was a winner, we do that. And then after 5 seconds, create a new game, and then show the board. I am using just stop it, Andrew. Please. Okay, what were we doing? I totally forgot. Oh yeah, diagonal wins? Is that what we're gonna do now? It just sounds so hard. Okay. This is the note from Doc, which we could potentially use. So we'll try this is forward diagonal win. Let's grab the board from the game state. We have this fancy logic, which comes from Doc. Sunco says, I have to say I really enjoy your streams. I look forward to watching and learning, so thank you. You're very welcome, Suncoast. Thanks for hanging out with us. This went wrong somehow. Slanting diagonal. Twitch chat pseudocode. Okay, well, we're gonna do our best. And actually, I should be able to reset the game so y'all can keep playing while I'm coding this. Course. Wait, no. Oops. All right, so it's YouTube's turn. You all should be able to play while I'm attempting to implement the diagonal win logic. Wait, did it just break? Oh, okay. I thought it wasn't on the bottom row. It is. It's Twitch's turn now. Okay, what is Doc saying here? Yeah, for y in 0 and 1 and x in 0, 1, 2, 3, 4, there's the win if x comma y is equal. So for any given location is equal to x plus 1, y plus 1, x plus 2, y plus 2, x plus 3, y plus 3, or x, y plus 3, x plus 1, y plus 2. Okay. Ravjot is saying, why don't we extract the desired arrays and check the winning condition for those arrays? That's actually not a bad idea. Like, if we know what are all the possible diagonal wins. I mean, I don't even have to do it on a physical board. I can do it on this array representation that we have. So here's a possible win. 1, 1, 1, 1. There's a lot of possible diagonal wins. There are a lot. Because this is also one. Let's number them. There's a lot. So, yeah, so Doc is saying, in that pseudocode, x and y is the top left of the 4x4 square where the two diagonals can be. Let's go back to all zeros. So we're thinking of like a 4x4 section of this grid. So we're kind of like breaking down the problem. So we're looking at this section here to check for diagonals, and then we could look at this section, and then this section, and then this section, all the way up to this column. Very similar to how we were checking wins like this, because we're looking at each individual 4x4 grid. And so we can look at this 4x4 grid, this one, we can go down one, and then over. So we really only have to look at the top two, shifting over. Okay, this is making a little bit more sense. Kalaradin is saying, the forward part is correct, but the reverse part is incorrect, as it can start at index y equals 1 and x equals 7. Yeah, so here, but y is 1. Yep. Heart donut. Anybody win yet? Nobody's won. It's YouTube's turn. They could take the win right here. YouTube takes the win. Well, it's diagonal, so it doesn't count. you can only win horizontally. I totally forgot. But yeah. Oh, nice. Heart-shaped donut. Alka made that emote. Okay. Implement the part before the or for the forward portion. Forward, meaning x plus 1, y plus 1. So this is forward diagonal, and then this one is x, y. 3? Okay, but yeah, I mean, where my mind was going is basically we want to iterate through all the different quadrants that a diagonal could be in, like the little square, and we're checking for the forward diagonal. Okay, so very similarly to how we were checking for, is it a winning row? It's actually going to be very similar, I believe. Let's copy this. So, wait, what? No. I want it horizontal win. Wait, did Twitch win? Oh yeah, Twitch won vertically. Wait, why didn't... It's supposed to flash. Oh, I forgot to do strip.show. Or did I? Color, winning color, show it, and then in 50 seconds. I meant to do 5. Oh, there we go. So, it should be a new game now. Doesn't say whose turn it is though. Shouldn't this have worked? We found a winner. Set the winning color. And then show it. That didn't work. I don't know why, but oh well. We'll look at that later. Yeah, this is wrong. Oh, well, no, not pixel, because strip.color will, or is it strip.show? Strip.color, I believe, sets the entire thing instead of just one pixel. Solomon is asking, do I recommend my keyboard? I am looking for a new one. I like it. I am not a mechanical keyboard aficionado, and this is a very inexpensive mechanical keyboard, but it works for me. If you do !keyboard in the chat, you can get a link to the keyboard. but yeah, it's cool. It's not the best. It's cheap. All right. How about this? I actually don't feel like coding anymore. Is anyone in the chat? Do you confidently feel that you could implement diagonal checking, win checking, in under 10 minutes? Who in the chat has that confidence? And also wants to, because you don't have to. Because I might actually open up a live share and then just let people edit my code. Alka says, I'm sure I could do it. Doug says, but I typed it out already. But I have to translate it. It's different. Oh, no. I just did the totally wrong thing. Not that. This. I could do it by 10 minutes tomorrow. All right. Do you want to join a live share? Let me hide my screen for a second. I'm honestly tired of coding. I've coded too much today. Outsourcing the stream. Yeah. We need coders. We need coders. We need coders that'll do it for free. Okay. It's gonna be read only for now. And honestly, I'll send this read only link to anyone. I'm gonna do this. So here. Literally anyone watching, if you have Visual Studio Code installed on your computer, you can click this link and join the session and look at all my codes. Ravjot says, I want to thank you for inspiring us with great projects and insights about various parts of development. You're very welcome. I'm glad that I can be an inspiration. I'm glad that I get to do this. This is fun for me. I really am. I don't know. Maybe I didn't get enough sleep last night. No, I didn't get enough sleep last night. I definitely didn't get enough sleep last night. Let's see if anybody joins. Alka's here. I'll give you rewrite access. Yeah, it should be read only. We got it. Like, honestly though, we got this working so far. I'm proud of this. I am proud of what we've made. I just have to get diagonal wins validated. All right, so we're gonna watch Alka code this. I don't know what to do. If you look at, there's a function called is forward diagonal win. This is the function that we need to fill in down here. Yeah, you got it. There's Alka. And this is Doc's pseudocode, but basically we need to check every possible diagonal to see if it is the same color and therefore is a win. So we're gonna watch Alka code. You don't have to look at my existing code, but you can see that I'm using the variables row and column. Doc is definitely using like X and Y, but it's up to you. Yep, and Hot Doggo is saying you can only get a diagonal win in row starting or ending 0, 1, 3, or 4. No, 0, 1, 2, 0, 1. Oh, row. Yeah. Doc, get in here. Yeah, I don't know. Which one's Doc? Are you in here, Doc? Are you planning on joining? I think you can do it, Alka. Here we go. Let's watch Alka solve this in record time. I think 0, 1 is the starting location. So let me unfollow you for a second, and let me tell you my thinking on this, Alka. So basically, we have to treat it like a 4x4 section, like all possible 4x4 sections on the grid, and each one of those we want to check for a forward diagonal. So the 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, like this is one box, and we first need to check this box to see if that diagonal is there. If it is, there's a winner. Then we move over one column and check this box of 4x4 to see if this diagonal is a winner. Then we move over to this 4x4 to check to see if this diagonal is a winner. Then we move here. And then lastly, we move here to check if it's a diagonal. But you don't move past this column because you couldn't have a forward diagonal win, at least starting in this grid here. So that's all possible diagonals there. Then you can move down one row, and you have a 4x4 grid here to check to see if there's a diagonal win. And you do the same thing, moving one by one by one till you get to the end. That's pretty much it. I probably could have coded that. There, Keller Arden has the code. No worries, Doc. I don't like. I appreciate the help that you've given. Oh, YouTube won. Did it flash red? Good job, YouTube. Yeah, and so you can do it the forward diagonal or the backwards diagonal. So let's see what Alka has decided to do. Follow. Wait, what's happening? It didn't flash red? Okay. Well, there's another game if you want to keep playing. Is this frozen? Regardless, I'm going to put the code that Collardin added in here just for a second. We have a syntax error? What's going on? It's frozen. Oh no. It's definitely frozen. Oh, my entire... I think somebody's hacking me. Dang it. I got hacked. Too many hacks. I appreciate Collardin, and actually, I'm gonna go with the code that you wrote. I should just write this thing. Okay. Yeah, so we're looking at each quadrant starting at row 0 and row 2. That's great. Column 0, 1, 2, 3, 4. So yep, this should be 5. Right? Is that what Doc was saying? Yep. Because we want to check all the way up to at least the 5th one. That's great. And we want to get the color at this particular index. So what you were checking here is if board at that index is equal to 1? Do you mean if the board at that index has a value in it? For colors, okay. And then technically this ampersand should work to see if it's not 0, but what we need to check is to see if it is equal to the winning color. And so this is checking row column 0, 0. Then it's checking, oh, this is the backwards diagonal. This is not the forward diagonal. This is the backwards diagonal, right? Can you confirm that? So this is checking like this, right? Down to right, yeah. So this is down and right backslash. So yeah, this is the that win, which is totally fine. We can, the logic is going to be super similar for forward slashes. So we can say if winning color does not equal 0, meaning there is a color there, then we're going to do some stuff. And then if all of this is the same, then we're going to return the winning color. Otherwise, we're going to return false. And this whole thing needs to go in the is backward diagonal win. Here. We need to grab the board from the game state. And we want to say if board, not this, here, board at get index of row +1, column +1 is equal to winning color. Yeah, so this is going to check the forward diagonal like this all the way across. Backward diagonal, I mean. Cool. Cool. Yeah, so the numbers change here if we're doing that. So if we're looking backwards, then we can go all the way up from 0, 1, 2, 3, 4, 5. So all the way up to column 5. No, this is right then. Yeah, this is right. Return the coordinates of the winning pieces. I'm actually, like, that's not a bad idea. I like that. Yeah, so we grab the first one, make sure that there's actually a color there, because if it's empty, then there's no possible way that you could have a winner, which is why I did this. And then we want to look and see if every single one is equal to that same winning color. And if it's not, then it's not a winning color. Yep. Okay. We're almost there. We're really close. We basically just need to do the same thing for the forward diagonal. Is forward diagonal win? And things start off a little bit differently. We want to go row. We're going to start at row plus. No. Yeah, 7 down to 3. Oh no, it's a 5. This is a 5x8 grid. So this would be 0, 1, 2, 3, 4, 3. Wait, no. It's the same loop, just different pixels. Okay. Yeah, because I actually don't want this to be row and column. I want this to be row plus 3. 0, 1, 2, 3. 0, 1, yeah, row plus 3. And column. So that's going to start it off in the bottom left. 0, 1, 2, 3. And at that same column. And then the next one we're looking at is row plus 1, column plus 1. Wait. Wait, what are rows? Rows are... Oh, -1. You're right. Yeah, because we're going up. -1. -2. And -3. What are rows? And I think this makes sense. So our initial row becomes where we're starting plus 3 because we want to be in the bottom left. Like, I keep pointing at this. I know you can't see this. Let's look at it in my code here. So if we're starting, our loop starts at row equals 0, and we first want to look at this one right here. So we want to do row plus 3, which puts us there. And then the next one we want to look at is that. So that's going to be this row -1. And this column plus 1. And the columns aren't modified. They stay the way they are. This is it. I think I did it. Didn't I do it? Please confirm. Row -1. Cheesy or perfect? Flashing the dots that one would be ideal. I agree. Did I do it right? Let me know. Please, confirm. Confirm. I think it should be row, column plus 3, then row plus 1, column plus 2. Well, no, we're checking forward diagonal. It could never just be row, because our row is starting off at 0, and we want it to be the bottom left start of the diagonal. Yeah? I think it's right. Let's do a quick, like this. Let's do a quick test. Oh, wait. Am I even using that game board? No, I'm not. Yeah, this isn't used anywhere. Okay, thank you, Kalaradin. I think it looks right. Looks okay. Let's try it. So let's try to just do this one. See if Twitch is the winner. Wait, no, is it colors.twitch? Yeah, colors.twitch. Like that. And then when everything starts up, we're just going to say show board. Not check for win. What did I call the function? Is forward diagonal forward diagonal. We really need to check forward and backwards, but this particularly is forward diagonal. So right here, all right. Wait, what happened? This should light up the bottom one from the bottom left, and then oh, we got back false. Pronounce it like Colorado, but with din as in dinner and the end instead of do. Coloradin. 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 So I'm not actually from Colorado, and people in Colorado call it Colorado. I say Colorado, not Colorado, but Coloradin. That's probably right. Ugh. So this didn't work, which means my forward diagonal is broken because it gave us back false instead of the Twitch color. Because this gave us a new board with that one. Okay, so let's look at our forward diagonal. We're gonna technically this would have taken place. Okay, so doc has what it should be, but technically this should have been when row was equal to 1. So right now row is 1. And we want the index at 1 column plus... Okay, that works actually. Yeah. Okay. Because we're going... I see. We're going from the top right to the bottom left instead... Because I was going from the bottom left up to the top right. But, okay, so this would be row minus 1, row minus 3, 2, and then row minus 3. And then we subtract the columns as well, because we're starting in the top right of the quadrant. Is it a quadrant? I don't know. This is the winner. Money! It didn't work. All right. Oh, but we're starting off at 0. Okay, I'm doing this. Okay, never mind. No negatives. Okay. All positive? Then that means it's exactly the same. That's how we have the backward diagonal win. No, rows are positive. Sorry. Rows are positive, columns are negative. Yeah. One, two, three. How is this different from forward diagonal? It's what we already coded for, for backward diagonal. But just to think of how this is working, let's say we start out with like row is 1. So we say row 1, and this is no longer column. This needs to be row column plus 3. We need to start there because that we're starting if we're starting in the top right, plus 3. So this gives us the top right one. Then we want the next. Wait, what? Screen blocker? What? Okay, now we want this one. So if row is 1, we want to increment it. So now it's row 2, and that becomes column. And column is technically 0 right now. Then this becomes column plus 2. And then column plus 1, and then column. And I have done what Doc has said. I don't know. Like, I say I'm tired of coding, but then I just want to figure stuff out myself. I don't know. I did not see the drop. I did not. Hello, Johnson. Yeah, I didn't see the drop, but chat has a 98.85. Great work. Check row, column plus 3. And then check row plus 1, column plus 2, row plus 2, column plus 1, row plus 3, column. It didn't work. Nice, Alka. That's awesome. The matrix starts at 0, 0, so the top left is 0, 0, but technically if we're checking these forward diagonal wins, then the one that would be checking this is when row is equal to 1, because it starts off in this quadrant. I haven't checked the other diagonal, no. Am I checking against the wrong winning color? Oh, wait, no. Row, column plus 3. Well, the start position is checked right here. And this is where we're setting the winning color, because if it's not set, then that means we don't even need to check it. But let's just log it, because it should at least make it into here. And it never does. Oh, I'm only checking one function at a time. So yeah, right now I'm only calling is forward diagonal win. That's the only thing that's running. Everything else is not being run right now. Get index at row column plus 3. Yeah, the winning color isn't even popping up. Wait, is that how my get index you pass in row and column, right? The rows are increasing because it's 0, 1, 2, so the rows would be increasing. Start at the row you're at, increase by 1, increase by 2, increase by 3. The column is over here, and we do add 3 to it. Next row, column plus 2. Yeah, so this looks right. Something's wonky. I mean, that shouldn't change anything. Oh. We returned false too soon. We did it. Okay. Well, so that's great. And huge thanks to Coloradan for helping us. How'd that happen? Coloradan gave us the code, but it's not their fault because I was literally just I was just trying to get their code working. Cool. So basically we need to do the same thing, but for backwards, and this goes here. Now I don't know how that'd help. Wait, what? Should be being continue first instead of like returning. Yeah. Okay, but for a backwards diagonal win, now I know how to get this working. So row column would be the starting point. Row plus, wait. Okay, this is different. This is different because row column would start here. Row plus 1, column plus, yeah, and this goes diagonal in the in that direction. So that one looks good. Okay, let's test that. And then we want to check, is backward diagonal win? We did it! Multi-cursor would save so many arrow presses. This is true. But I'm tired. I gotta go. We should flash the pixels that are... we should flash the winning pixels. We really should. So I think that's the last thing we're going to do. Instead of the winning color, we are going to we're going to return that entire, all the indices of the pixels that we need. I mean, really, I should store these in variables because I'm gonna be reusing them. Oh well, we're just gonna hard code it. It's fine. Why is it row plus 1, column plus 2? Here? You have to think about it. We're starting at the top right of the quadrant. So the row goes down 1, so that's increasing because the rows increase. And the column in the loop starts at 0. So we want to increase the column to reach the end of the quadrant. Hopefully that helps. I think this is the main thing. We're looping from 0 to 5. Okay, so that returns the winning indices there. We need to do the same thing here. Alien! So we need to do the same thing for rows and column wins. So I'm going to do this. Oh. I mean, really, right here it should be... It's returning undefined, which is the same thing, I guess. Indices? And then we need to do the same thing for winning column. Wait. And then instead of returning true, we return the indices, which is an array of all of the indices of the pixels that we were going to need to flash. Okay, this code is so messy, and there's a lot of it, but when we're checking for the win, which is right here, winning indices, let's check for win. So we can create a variable for the winning color, which is going to be the board at that given, at the first winning indice, which is the color of the winner. So that's our winning color. But now that we have the winning indices, we can actually flash them. So winner, and then right here, we'll just have like an in-game where we're gonna pass in the winning indices. And then in-game, hey Greg, what's up? We are about to finish this Connect 4 game, this collaborative Connect 4 game that we're coding on a RGB LED thing. Okay, so we want to flash the winning indices, let's say like 4 times. Really, so let show pixels false. And then we'll say winning indices dot for each. Well, and then we'll pass in the winning color as well, because that's the color we want to flash on and off. That. So for each indice, we're gonna grab the board from game state. We are going to set that board at that index to be 0. Wait. I can't think. I need to go. That would have we would have been done already. We basically implemented the collaborative art at the beginning with the top row. So I'm glad we did this. It was pretty complex, and it'll be fun to add new stuff to later. So for each of those indices, we're going to set it to 0, and then we're going to show the board. And really, I shouldn't call this in-game. Let's just call this... I need to rename this. Let's call this Flash Winning Pixels. Flash Winning Pixels. And then initially, show pixels is false, like that. And we'll pass that in. So we'll show the board, and then in... 1 second. We'll call itself with show pixels as true, like that. So we can test this really quick. Because here we were doing is backward diagonal win. This is the winning indices. And what we want to do is say flash winning pixels with game state dot board at winning indices at 0 is the winning color, and the array of winning indices. So when I start this up, it should just flash that diagonal win. Though, did I change it back? No, I didn't change it back. So, if this if this is right, it'll flash those pixels. Well, they just all turned off. I might have forgotten to do board.show. Oh, I need to flip the logic to if show pixels is true, set it to the color instead of 0. like that. Yeah, gotta turn them back on. Cool. So that's great. Let's flash. Yeah, let's flash them faster. Faster. 300 milliseconds. Recursive Stack Overflow. That's good. That's the winner. Okay, cool. So we could do like a total number of flashes. So we want to flash it, I don't know, 20 times, and then we'll like officially end the game. So we'll say if count is less than 30, then keep on doing it. Otherwise, we need to restart the game. And so, where were we? We're checking for the win. Okay. We flash the winning pixels. That's going to keep flashing. And then when we're ready, we're going to reset the game, which we can do. I believe we have the technology to do that. So at that point, I believe we can just say new game. Game state equals new game. And then show board. Yes, this is a family-friendly stream, so we don't really talk about things like that here. Okay, this is it. This is the winner. Excuse me. Oh, I need to update the initial stuff that's happening. Did I ever increment count? Yeah, it's a recursive, well, not recursive function, because it calls itself after a given timeout. But yes, I passed in count +1. At least I believe. I'm going to double check because you asked, but I think I did. 1, 2, 3, 4, 5. Cool. And then the initial game, we'll just show the board. Yeah, I mean, I guess technically this is a recursive call. It's just a delayed recursive call. Count +1. Yeah, this is it. All right. We're going to try once to play the game, and if it breaks, we'll probably fix it, but I kind of don't want to fix it. So, YouTube, you're up first. And oh, so for those of you that just joined the stream, !C4 is connect 4, and then you put the column that you want to play in. Okay, so YouTube has played, and that came from Christopher, who did column 4. So now it's Twitch's turn. So Twitch has Daniel Garden has played column 6. That's great. Now it's YouTube's turn. Very good. Column 3. Like, it would be nice to have an actual grid so you could see where the columns are, because it might be actually a little bit hard to see where the pixels are. All right, Doc with the column 2 play. YouTube's turn. And Ravjot with the column 2. Twitch's turn. And for those of you that are just dropping by, this is a real physical RGB LEDs that we're lighting up here. There's a webcam right here. All right. It's Twitch's turn. It's a good game so far. Lots of action. Shaggy with the column 2 play. YouTube's turn. Riveting game. So riveting. Ravjot with the column 1 play is pretty good. Twitch with the column 4 play, and they have actually left open column 2, or technically column 1, for YouTube. Off by 1, yeah. Wait, are these in the wrong columns? Yeah. Oh, no, they're not. Okay, so Twitch has stopped YouTube's attempt for a vertical win. They still have a chance by playing the diagonal win. And it is YouTube's turn. Where are they going to play this time? All right, they've gone with column 5. Twitch's turn. This is not looking good for YouTube. If a fast YouTube play comes in that's not thoughtful, they may not be able to stop Twitch from winning the horizontal win. And they have not stopped them, so if someone from Twitch can play column 0, 1, 2, 3, 4, 5, 6, Twitch is the winner! Oh, and it broke. Dang it! Oh well. Twitch won. Robbed! Alright, let's see why it broke. Winner undefined. Well. Winning indices for each. Okay. Wait, great game, everyone. This is Connect 4 line 279. Yeah, so wherever I called flash winning pixels, well, not here. This is the definition. Not in horizontal win. It's the in-game condition that messed up. Here. Check for win. Winning color and winning indices. Maybe horizontal win isn't returning the indices correctly. That's possible. Let's see. We started off at the first index. Wait, no, this is column. We want is winning row. Started off at the first index. That's the index, and then we push it in. It should be. Let's log the indices. We can replicate this board and then try the end game state again. Here. Yeah, because technically, winning indices at 0 should give us an index. And if we index into the board, we should get a color. Though that is not working. And teams is a variable that has the colors. And that's not working either. Cool. Let's just replicate this game state and see what happens. So, no, I mean, technically, oh yeah, nobody played in column 0. I guess that's a little misleading. Or not misleading, but could be confusing because nobody played in column 0 because they were doing column 1. 4, 5, 0, 1, 2, 3. 0, 1, 2, 3. Okay. This is going to be colors.twitch. How well would this work in PHP? You would just need a library that can communicate over serial in PHP. I don't know if that exists. Yeah, everybody asks for 0 index and then nobody uses it. Okay, so this was the winning play right here. And let's just try it out. Show the board. Let's see if check for win. I know this isn't great, but I'm just gonna copy paste this. Winner undefined. Wait, it didn't log the winning indices. Oh, I know exactly why. I know exactly why. So, I have this is winning row. It's returning indices, and then horizontal win actually needs to return the indices. Like that. Let's make sure we do the same thing for a vertical win. Yep. So what you said, yes, probably. Like I said, I'm tired. Oh, buddy. Wait, why are there 5 indices? There should only be 4. Okay. If color at row and column equals color at row plus 1, column plus 1. Yeah, I think we figured that out earlier. Yeah, why was this printing 5 indices? That would have came from here. Oh. Because our for loop is starting at the start column. This should technically be start column plus 1. Cool. I'm curious why it's not flashing though. Because we're doing flash winning pixels with the winning color and the winning indices. Flash winning pixels, show pixels is off, count equals 0. It should be flashing, right? This should be flashing. Oh, okay. Team's winning color. Oh, Count plus equals 1, not... Well, count plus 1 will work. It is a recursive call. Because we're not modifying the variable, we're just calling the function again with a new value. Why did nothing log? Oh, well, I wanted to show whether it was Twitch or YouTube right here. Winning indices at 0 on the board. Where's the board coming from? Board is... here. I am, though. No, I am. Check it. So, when I first call this function, it has a default parameter of 0. And then when I call the function here, I'm calling it with the current value 0, or in the first case, it would be 0 plus 1. And then the next time around, it'd be 1 plus 1. So, it's fine. It's fine. All right, why is the color... undefined? Come on. Oh. No, we have the winning indices. And we're logging those. It's 27, 28, 29, and 30. (27, 28, 29, and 30). That's the right ones. And so our board... Oh! In this particular scenario, this is GameState.board. It would have worked in the other place because the variable was actually the right thing. Board was referencing the actual Arduino board, not the game board. Yeah, okay. This is it. All right, we're gonna do one more game. Oh yeah, and let me make sure I'm doing all this right. Okay, this goes back to a blank board. And then the winning check. Yeah, in this scope, board is from the game state, so that should be okay. Yeah. Game board and Arduino board. That would make too much sense, Andrew. I don't think I'm gonna do that. Make way too much sense. I think I can do teams at the winning color. Right? Okay. It's now or never. This is it. The final Connect 4 battle of the night. First up, Team Twitch. And don't forget the columns are 0 based index. So there we go. Acid Spark with the column 0 play. Strong start. YouTube's turn. Ravjot with the column 3 play. Spreading it out, not bad. Ember with the column 0 play. All right, if I were YouTube, I would probably play column 0 to stop this potential. There we go. Got Ravjot with the column 0 play. Twitch's turn. Twitch with the column 4 play. Little interesting. Did not expect that. YouTube's turn. Yeah, and so the way it works right now is if you sent a command before it was your team's turn, that command is just ignored. In the future, what we want to do is I'm going to hook up this LED, which will show the person's name whose turn it is. So for each team will be made up of either Twitch people or YouTube people, and this will say, like, YouTube's turn. Ember, your turn to play. And so it'll rotate between all the players on a given team. Right now, it's just the first command to come in. All right. YouTube is building up their diagonal play. Daniel Garden with the column 5 play. Not bad. YouTube's turn. Column 1 play. I should probably add timeouts too, so the same person can't, because Ravjot is getting in there early. Like Ravjot is getting all the plays, which is not a bad thing. But in the future, we can stop that. But also in the future, it'll cycle between all the players on a given team. So it'll say like, "Hey, Acid Spark, it's your turn." All right, YouTube is 1 play away from a win if Twitch does not go in column 0, which they do. So they have blocked YouTube's potential Connect 4. Great work, YouTube. Oh, Twitch with the column 0 play. YouTube could take it right now, but they chose the wrong column. They counted in the wrong direction, so Twitch can stop them from this Connect 4. Actually, no, it's a 2-way Connect 4. YouTube's gonna win no matter what, as long as they either go in column 3 or column 4. What are they gonna do? Yeah, they won. This was a good YouTube play. They win either way, and yes, it works. It works. Great work, YouTube. YouTube with the win, and yeah, great work. And the game starts over. Yeah, good work, everyone. Yay, we did it. Yeah, I'm a shoutcaster for Connect 4. All right, that was super fun. Okay, thanks everyone for hanging out. Thanks for sticking with me. For a second there, I kind of lost my motivation and almost didn't code the thing, but then we coded the thing. So that was fun. Thanks. Shout out to Doc. Shout out to Coloradin. Shout out to Alka. Shout out to anybody else that helped out tonight. Super, super fun. And I'm gonna. What does it look like if I take this off? You know what? Let's do this. I want to see if I increase the brightness. Thank you, Kamal. Thank you, Sacred Gaming. All right, somebody play from Twitch. Yeah, I want to see what it looks like when the LEDs are like super bright. Nice. All right, I'll let that keep playing. Thank you, Daniel Garden. Turn off the lights. Then my blue screen would stop working if I did that. But okay. Let's find a Twitch channel to raid, and then we're done for the night. Doo-doo-doo-doo. The light burns. And so if you're watching on YouTube, head over to twitch.tv/codinggarden, and we will we're gonna raid a channel. And Ben says, proud of you, honestly. Oh, thank you, Ben. Thank you very much. Let's see who's streaming. Oh, Mastermind is streaming. Let's see if they just started or what's going on. Cool. Yeah, we'll raid Mastermind. He's teaching about AWS tonight, so that seems cool. Oh wow, Twitch can win right now. There we go, Twitch with the win. Nice. Cool. This was fun. look at all the jumps. Oh, I'm glad we got it working. That was great. Okay. We are gonna raid Mastermind. It's a really cool channel where he has a totally free DevOps and coding bootcamp, and tonight he's teaching about AWS. So that's fun. Look at these drops. Oh, look at Alka with the GIF. Nice. The translucent tape instead of paper. Let's just see really quick. Well, this is not translucent. This is just that one's clear. Let me try it. I don't care. I'm done. Let's do a raid. Again, thanks everyone for hanging out. Thanks for being nice people and having fun with me, because this was a good time. We're gonna raid Mastermind later. Yeah, I'll do it later. All right. Or thank you, Kamal. Have a good day. It's pretty early there. Oh yeah, let's get our raid message ready. Wait, that's the wrong thing. Who can get the raid message? We're gonna run out of time. There we go. Shaggy's got the raid message. So copy paste that. We're gonna send that when we head over to Mastermind. Be super nice, and we're gonna learn about AWS. So thanks again for everyone for hanging out. Wherever you are in the world, have a wonderful morning, afternoon, evening, or night. And until next time, here's this.